Hello, everyone, and welcome to Pactober. Thank you, everyone, for turning up. I know we have people from all over the globe. So for those in UK, Europe, and Africa time, good morning. For those in Asia and Australia, good evening. I know that this is starting to cut into your evening, and thank you for coming. And for those in the Americas, very early good morning to you, and that's very early there. I hope you've got plenty of coffee. We've got some really great content today, and I really appreciate that you've taken time out to join us. So first thing, as you probably realized, is we are streaming on YouTube. So this will be up there anyway. So if this is too early or it does get too late, obviously you can come back to it. But obviously we want to have your participation, because obviously we can answer questions now, and that's what we're trying to do through the day. So we've got a stacked lineup today, but first we've got to do a little bit of the housekeeping. So first thing, code of conduct. So I've got the link up here, so docs.pact.io contributing, and then from there you should see the link to go and see what our Pact's code of conduct is. Very basic sort of principles is be welcoming, be inclusive, and obviously be respectful. We obviously have difference of opinion, and just respecting those as we go along. If you do have any concerns, we do have a group, we do have a cohort listening on slack.pact.io. So for those who aren't registered on that, I know a lot of you will be. Please feel free to go there. We've set up a special channel, Pactober, just for that. And if you have a concern, myself, Yusuf, or Joe will be in that channel. Feel free to reach out to one of us, and we'll try and address it. Generally, though, if you have any questions during the day, we suggest you can ask in there. We are also monitoring the YouTube channel, so you can put them there as well. But that'll be the best. So we'll either try and answer in place if they're a really quick question, or we'll try and surface them at the right time. We've got some really great speakers, and generally I'll try not to interrupt the speakers as they go, because their content's generally pretty awesome. But I'm sure, especially with some of the content we've got here, that there's going to be some people who want to ask some stuff. We'll do that time dependent. Anything we can't answer, we'll try and answer offline on the Slack channels anyway. So we'll try and get through some. But we have got limited time today, so with the content we have, so bear with us. And the other thing is we're always trying to improve and make things better. So please feel free to give us feedback. We've got a type form. So at the end of the day, we'll try and I've just realised we've got to do a live edit on the day, because we've got to get this form at the this link to you at the end of the day, so you can redo this. But just so that we can improve, this is only the second time that we've done this, and obviously some dynamics. We're all online these days and remote, so some sort of so what we can do better would be great, and also what we did well. That's always good to hear. So generally, we've got any questions during the day. We've got a little bit of an overarching thing we'd like to know, because this is we are all online. It's a global thing. It'd be great to hear if people are comfortable with it, sharing some of the interesting places they're from. We've got one or two of our speakers are from particularly interesting places. I'm based in Cambridge in the UK. If you can't see the map behind me, the pub underground map that's behind me. And I don't think that's exotic, but I'm sure there's some people out there who probably do think it's exotic. So if you've got some funny anecdote about where you are, please feel free to share with us during the day. So that's the kind of the boring logistics stuff. What we kind of hope that you get out today, and some of the driver for this was, firstly, Pact as a thing is 10 years old today. So Matt, Beth, and Ron especially wanted to, have a way of celebrating that milestone for an open source project to go 10 years and still be growing strong is a great achievement. So they deserve a lot of kudos. So this was originally born out of just sharing it. So a little bit of nostalgia. But also, hopefully, when we go through some of the talks, especially with Matt, Beth, and Ron today, some of you who are using Pact or interested in Pact, you'll understand, and contract-based testing, you'll understand why things are the way they are, and the direction that we're going in. I know we've got a few great anecdotes from Matt, Beth, and Ron coming up very shortly, including, I had a sneak peek, we've got the pen story, which is pretty funny for if you were there at the time. So that's really good. So there's that celebration, and also kind of letting you understand why things are the way they are. We also, obviously, anytime you do this, contract-based testing is still a very new concept. It was born out of doing this very much for RESTful APIs, but the world's moving on. So trying to grow awareness, grow to 10, get more people interested in this. So hopefully a lot of that content we have today will build upon that. And the last thing, as an open source project, I mean, I know there's Pact Flow, and there's a commercial side to this now, and that's a really great open source story. But at its heart, most people still use the open source libraries that are available. And it's really hopefully trying to pique some interest in a few of you to put your hands up, join us on Slack, and see how you can contribute. There's a whole variety of things. You don't need to be the best engineer in the world, but there's a whole bunch of things and different ways that you can contribute to Pact. I don't have much time these days. I used to maintain Pact Python, but these days I get ensnared to do these sort of events. So apparently that's the best use of my time apparently these days. So anyway, moving on. This is our schedule. So I'll try and run through this. So you've got me wittering on. So I'm actually running ahead of time. So I'm clearly speaking too fast. But then we've got Beth, Matt, and Ron. So this is going to be a hello from the Pact Core team, and a little bit about the history, a bit of nostalgia, a little bit of a celebration. So hopefully you find that really interesting and engaging. Then we've got Sam Newman. So he literally wrote the book on building microservices. So really, really amazing speaker. So we'll have him at British Summertime, obviously, 10:45. I'll let you do your adjustments locally. So that'll be our opening keynote. Then Yusuf, who is basically my partner in crime today, I'll introduce him, and he's got a fireside chat from 11:45 for just shy of an hour with Lewis Prescott, Baz Dykstra, and Dave Farley. So I'll do some intros, so some really renowned QAs and continuous delivery folks there for us to share their thoughts. We will have a comfort break at 12:45, and when we come back, we will get some updates from various contributors for the different libraries around Pact, so you can see where they're at, and also a little bit of vision statement and future thinking from Matt himself. So it's a really good opportunity for you to get to see people who do a lot of the work behind the scenes that a lot of you get to take advantage of in your day jobs. We will then, just because of timings, we will have another short break, and we're going to have our closing keynote will be from a gentleman called JB Rainsberger. So I'm really, really stoked that we've got JB talking. We are a little bit subject to Air Canada and hurricanes in North America, but we are confident that he will be here in time. So you may have to listen to me for 5 minutes bridging the gap, but he's assured us that he is due to make back on time. So we're fingers crossed for that. And he's got a very, very famous talk around integration tests are a scam, which I think we've now got a slight revisionist, a more empathetic version that we will be getting today. So that's, and then I will be wrapping up. And as we go through, I will try, if there's any relevant sort of questions, I will try and ask them time permitting at the end of each section. And then we'll try and, depending on what time we finish at 3 o'clock British Summer Time, I will try and go through them. I say any we don't get to answer, we will endeavour to answer on the relevant forums, mainly Slack, to the best of our ability after. So apologies if we don't get through to all of them. Okay, so I believe that was my intro. I am a few minutes ahead of schedule, but if you're ready, Matt, I was going to hand over to yourself.
Absolutely. All right. Well, I don't know why. Funny enough, I can't show up my screen today. So after all of that talking beforehand, I'm going to need to try this again. Okay. it's magically appeared. Okay, hopefully you can all see that. Thank you, Elliott, for the awesome introduction. We'll start by saying, happy birthday, Pact. I've got my old fashioned actually. It's 8:10 p.m. here, so sorry for those in the UK or anywhere else in the world where it's maybe not very appropriate to be drinking, but it is a birthday party after all. I want to start as well to sort of just maybe put a bit of this into context, and we're going to spend a bit of time talking with Ron and Beth here. But let's just cast our mind back to the past and sort of think about the last 10 years of Pact and kind of where it came from. It was actually 17 years ago when Ian Robinson penned an article on Martin Fowler's website that introduced the concept of consumer-driven contract testing to the world. He described an ancient world in which the state of the art architecture included these primitive systems, so SOA with SOAP and XML, and they weren't always living up to their promises. Quote from this article: chief among the benefits of service enabling an enterprise's application landscape are increased organizational agility and reduced overall cost of implementing any change. An SOA increases organizational agility by placing high-value business functions in discrete, reusable services and then connecting and orchestrating these services to satisfy core business processes. It reduces the cost of change by reducing the dependencies between services, allowing them to be rapidly recomposed and tuned in response to changes or unplanned events. Sounds really familiar, doesn't it? He continues, a business can only fully realize these benefits, however, if its SOA enables services to evolve independently of one another. To increase the service independence, we build services that share contracts, not types. So here he's referring to things like WSDLs and XSD and other SOAP technologies, at the time. And he calls these provider contracts to reflect the narrow provider-only view of such technologies. He goes on to describe many of the reasons as to why these benefits aren't actually realized in practice. Hidden coupling, inversion strategies being the two primary challenges, and how an alternative approach provides a more reliable way to evolve our services independently. And this is, of course, consumer-driven contract testing. A few years later, in 2009, J.B. Rainsberger, who we'll be talking later, as Elliott mentioned, penned an article called Integrated Tests Are a Scam. And this was somewhat controversial at the time. I was actually looking through Reddit earlier today when I Googled the term actually, and I was looking through Reddit, and there was some really scathing kind of, comments there, to be honest. But anyway, it challenged the prevailing way we tested systems. And at the time, this really did reflect an over-reliance on end-to-end integrated testing, and that was causing all kinds of problems. As Elliott said, we're going to get a refrain or somewhat of a refrain on that talk today that none of us have seen. So who knows what's going to come of that? He might decide, this is just a terrible idea and it's all for nothing. Anyway, fast forward a generation and RESTful services were the new standard or are the new standard for APIs and microservices. And microservices, were fast becoming the architecture du jour. However, of course, it too had challenges. In 2014, at YOW, which is a conference here in Australia, in Melbourne, my colleague Beth Scurry, alongside Evan Botcher from ThoughtWorks and John Eves from realestate.com.au, unveiled a tool they called Pact that was built in 2013 whilst implementing such an architecture at REA. They were enjoying many benefits that microservices provided, similar to the kinds of benefits we heard earlier, actually. However, it proved really challenging, or particularly challenging, around the processes for testing and releasing. And they realized the insights from these kinds of concepts and articles applied equally to RESTful services as they did to those architectures discussed earlier. And they created a tool from these ideas, subsequently open sourcing it. So for me, this is where my story with Pact begins. In 2014, I discovered Pact and became a contributor in the same year after it was introduced at my first consulting client. And I really saw the impact it could have on an organization's agility. The thing that really blew me away was just the ability for developers to work a lot more closely with the product team and the testing team. And this was also around the time of DevOps and sort of cross-functional teams where that was established. But the relationships and the way teams work together was just vastly improved by the ability to deploy more quickly. And that change around removing end-to-end integration tests or very much reducing them was key to that. Anyway, I was totally hooked, and both with the project itself and just as importantly, the love and enjoyment of creating something that others could benefit from, open source, right? So at the time, I had absolutely no idea, of course, the opportunities that would bring and the impact it would have on my career. Those are my colleagues and friends, and of course, developers across the globe who get to use Pact every day and hopefully benefit from it. So we'll discuss the relevance of contract testing in 2023 and beyond of Pact later today as well. But for now, I'd like to take a moment to reflect on the beginnings and get some insights from Beth and Ron, as well as myself, and these are people who are just instrumental in taking Pact from this internal tool at realestate.com.au to the popular open source tool it is today. So welcome, Beth and Ron.
Hello.
Okay. Hello. Yep. You there, Ron?
I'm here. Hello.
There he is. So we're actually really lucky to have some footage from the archives here. This is actually a photo that Beth has taken, I think circa 2013, 2014. Please comment, Beth, of her explaining how Pact works to another team at REA. Let's start with a few reactions. Beth, how do you feel when you see this? What comes to mind?
Well, looking at that, my first thought was, man, the messaging has not changed. Like 10 years later, and they're exactly the same points we make, and nothing has changed in 10 years. Like we've just got more microservices making a bigger mess now, so they're even more relevant. But yeah, things, time goes on, things don't change.
Yeah, absolutely. Ron, anything from you? Like, how did the team come up with the idea in the first place? I think you were there right at the origin story. I can see your name is mentioned on that board. If you can all see,
yeah, I wasn't
left-hand side there.
I wasn't involved with the actual origin of the tool. I was on another team, but at the same client. I'm just quite interested to see that the inverse of VCR was, not many people know, but VCR was a way of recording things and replaying it back. And this was quite an interesting thing. It's like going along a similar lines, but you're doing it in the reverse.
Absolutely. We got a couple more photos, so let's have a quick look at the next one. Oops. Oh, what's going on there? Oh, yeah, there we go. This is a fun one. I think this is what you alluded to before, Elliott. This is the pen that Beth used to explain Pact to Martin Fowler at approximately 5:30 p.m. on 18th of June, 2014. Beth, I actually have a really big surprise for you. We're really fortunate to have someone special on the call today. The pen. No. Tell us a bit. Bad joke. I did actually have a pen that looked like that. It's not the same one. Do you have what do you tell us about this event? What was going on?
This was like a developer's like celebrity excitement moment. Yeah, it was the highlight of my career at that point. Definitely having a chat to Martin Fowler.
Did you keep the pen?
I have no idea where the pen is.
Does anyone know what happened to the pen?
I did find the piece of paper at some stage later, I think, when I was cleaning out my desk at some stage, but who knows where the pen is.
Yeah. There's also apparently sat in a chair as well. So I suspect these have all been put away into some kind of special archive for... Yeah. Do you know if the paper was ever taken down there, or is that just like the special chair that no one can ever sit in again?
It is lost to the time, the memory of time.
Lost to the ages.
Mm-hmm.
Before this, Beth did a bit of archaeological digging as well and noticed that the first change from an internal project to a public one actually went through Ron's GitHub account. Ron, can you tell us a bit how a project internal to REA, which is the company where this all started, made its way onto the internet?
Well, the problem REA was they're a real estate company. They're not an open source company deals with open source at the time. And so while we thought this looked like a really awesome tool and it was going to be really useful for us. And we thought, yeah, maybe there'll be one or two other people that, will also like to use it. But we really struggled to get them to approve using it open source. We had to get lawyers involved, and the lawyers will, they're busy reviewing contracts for customers and stuff like that. They don't have time to look at open source, and not a lot of our lawyers really understood the legality of, open source licenses. So they were kind of dragging their heels, and I just thought it was just too good a tool to not make available. So I put it up on my GitHub in the interim while we waited for REA to come back and approve, and then later we moved it over to their GitHub.
Yeah, it makes sense. I mean, I wonder how many good potential open source projects never made it to the internet or for into other people's hands because of those kinds of problems. It's interesting. Well, maybe because you were there at the start as well, or at least you were in the building, so to speak, when it was all happening. What was the driver for the project? We kind of alluded to it before, but we were reflecting on this, and I know that there was some brown bags at DS, and what was the thing that led to you going, that we should open source it? Like, yes, we knew internally, or you knew internally at the time, that the tool was interesting and it was solving a real world problem. What was the point to go, we should open source this? What was the driver and trigger for that?
I think, well, the main use case that we had for it there is that we had different teams. I think there were 5 different teams. And the actual team that made the Pact tool itself was doing the web app, which was the consumer of all the backend services, the microservices. So we had different teams building microservices, and we had a team building the web app, and they couldn't wait for the other teams to build all the services. They wanted to get going from the start. So they really built Pact as a mocking mechanism, so they could carry on their work. And then once all the other microservices come online, they can just be verified, on the Pact. It was a very clever idea. So it got them up going, and then the rest of us could kind of feed in as the various services are created. But I mean, just seeing that value of not having to build these large integration test environments to test, like 20 different microservices and, make sure that one's safe to release, just seemed to hold a lot of value. And it felt like it was just too good to, keep in the bowels of one company.
Yeah, I know my recollection as well, Beth, is that you were doing a brown bag at DS and around maybe JB's talk. Did you want to take us through that? I think that there was some crossing over of like communities and problems.
So I think I watched JB's talk and then gave a brown bag on that at DS. And at the end of the talk, I asked, so has anybody heard of any tools that allow us to do this, like decoupled but still connected unit tests on both sides kind of approach? And nobody said anything except for Ron, who said, actually, we've just started this thing at REA. We've been using it for a little while that basically does exactly what you're talking about. So I think it was something in the air around about that time as everybody was kind of dipping their toes into the world of microservices.
Yeah, I love that. I love that. And that's the whole value in communities and things. And I do feel like I've not been able to contribute to some of those meetups, especially with COVID and the cross-pollination of ideas, right? That's where kind of, I think there's like a lesson to be learned here, that like the power of ideas and sharing those ideas around and how fast they can sort of take off. Ron, I've got one final question on this for you, which is somewhat tangential to this. If everyone looks really careful, you'll see his GitHub handle is Ugliog, or I don't know. Can you explain us your handle? I think I've, in the 10 years ish I've known you, I don't think I've asked this question, and it has actually bugged me.
Oh yeah, and I've always refused to tell anyone why I have that. Well, I suppose I can tell you now. It started up in university. We were just mucking around, and we had this thing. Is like, everyone, why don't you come up with an orc name? Like, if you're an orc, what would your orc name be? And then at the time, I think we had Netscape was offering free email, and so I used my orc name as the email address for Netscape. And a little while later, then Hotmail came along, and then I discovered I could just get Hotmail, where everybody else had to put numbers on the end of their usernames. Nobody had my orc name. And just through the years, I could just sign up for Oracle. I used the same thing. I've used it everywhere. I've actually stopped using it now, because obviously it's now uniquely identifies me, and it's an identity theft risk. So I don't use that. I still use the GitHub handle. I don't use the email anymore. But it's an orc name.
Thank you so much for asking that, Matt.
Was it bugging you as well, Beth?
It was bugging me.
Yeah, to something about working too long together, Beth. All right, so that was me just kind of trying to get us started, but let's keep the chat going. I have two questions before we do actually. Beth, true or false? You refer to your 2 human children as, quote, your second and third after Pact.
Yes, true. I call Pact my first baby, even though I did not invent Pact, didn't not write the first version, but it's my baby.
You're like you're like the mother who's adopted.
I adopted it.
You adopted Pact. Yeah.
Yeah, I think it's actually the Pact broker, isn't it? That's your real first baby.
True.
Yeah.
Kind of both. Was, yeah. Maybe that's my second baby. my actual children can be my second, third, and fourth.
Yes, Pact spawned a bunch of extra dependencies as well. Does your family understand what you do for a living in your free time? How do you explain it to your family?
Matt, my sister actually saw your post about the Pactober celebrations, and she screenshotted into our family WhatsApp group and said, after 10 years, I still have no idea what this does or what you're doing. And my mum actually had a decent go of explaining it to her, and I was quite impressed with her summary. And my explanation to Erin was, I make sure that the online shoppings work.
Yeah. I normally go with a similar answer. It's like, what do you do? It's like, you have like your mobile banking app or something, and you have to like make a payment or log into it. If you can't log into it, that means it couldn't communicate to some other thing. We make tools to help you prevent that from happening. And they go, oh, okay, that kind of makes sense. So you work in IT, right? Can you fix my Windows setup? I can't log in. No. Ron, do you have any explanations for how you do this?
Sorry, how I do what?
Sorry, how you explain what you do to your family.
Oh no, my family has no ideas. But my son was really astounded the one day he Googled my name. And obviously the kids in his school must do that, and they Google their parents, and all the other kids didn't find anything, and then my name came up on a whole lot of YouTube stuff, and he came and stormed into my room and said, why are you on YouTube? So I had to explain to him all about Pact, all about Pact and Flow, and he doesn't understand what it is, but he was quite in awe.
That's really cool.
Nice.
Did you guys have any questions?
Yeah, I've got a couple of questions. All right. If you could go back and give yourself some advice to yourself 10 years ago, what would you say? Ron, do you want to start?
Yeah, I think don't work so much after hours. The first couple of years, I was nearly every weekend and spare moment and evening that I could get away from family and other commitments I spent on this. I think I should have. Eventually, you burn out. So just, the need will always be there. Just pace yourself.
Yeah.
Yeah, it's good advice.
I think I know what yours is, Beth.
Yes, everybody knows what mine is, but I'll let Matt go first.
Yeah. I thought about this a little bit. Like, if I had to go back 10 years ago, I suppose I joined in 2019, so 9. But I think definitely what Ron said as well. Like, just making sure you get sustainable pace. I think you can definitely get really energized by something and just spend all your time on it. I think as well, like, something I've learned about myself, not just through Pact, but through working, is just knowing when you've got your energy, like your energy levels come and go. So when you've got that wave of energy, just like ride it and enjoy it. And when it kind of goes away, like, feel free to sort of step away a little bit. And I think definitely sort of maintaining a community is hard, and being part of a community is hard, because you feel like you've got a bunch of dependents that are waiting on you, right? So whatever you do is affecting them, right? And then it usually surfaces through bug reports or questions. It's like, this is a big problem for us. It's blocking us from doing X, Y, Z, and or you perceive that urgency, and you sort of take that mental load on board. So my advice to myself, or at least my advice to the project, would be like, how do you, if you know, you never know if a project's going to be really popular. Like the amount of stuff I've built that goes nowhere, you don't know. Sometimes it might take off for reasons out of your control, but if it does get to that point, it's kind of processes, and I think help, because you can just go, this is the process we're going to follow, and make it clear to others. There's no expectations, or the expectations are X, Y, Z. And I think if you put the expectations on yourself, you're wearing that mental load, and you kind of only have yourself to blame, if that makes sense. And I've definitely taken on a mental load without protecting myself against that. So I think that would probably be the number one thing.
Yeah.
What do you think, Beth?
Like
what was your...
It's a bit like the boiling frog thing. Like you don't realize that it's gotten to the stage where you need processes until it's so big that you have all the problems. All right. So everybody knows my biggest regret about Pact, which is naming the application that it participates in a participant, which is an incredibly uncharacteristic decision of mine, because I hate puns, and I don't know what I was thinking, but at the time, like 9 or so years ago, it was going to be a little internal project that would be used in REA and maybe a few DS clients. And then 10 years later, you didn't realize that participant would still be haunting you and have completely ruined your ability to actually type the word participant at any stage.
You also can't type the word contact.
Yes, contact as well. While I was thinking about this question, the other thing that I would tell myself 10 years ago is, don't make the Pact logo use the PACT capitals, because you're going to spend the next 10 years going, it doesn't stand for anything. It's just a word. It's not an acronym.
Definitely.
Sorry, Matt.
Sorry, you go. There you go.
All right. Well, it's been a long 10 years. What has kept you guys going? Well, I guess, Ron, you've been in here for 10 years, and Matt almost as long. What's kept you going for 10 years?
You can go, Ron.
Yeah, I think it's that every so often somebody just tells you, they give you something, a really great bit of feedback, right? That's really worthwhile. It makes your day when someone says, you know what, I had this big problem. I found this tool. It's really great, and for these reasons. And you can feel the appreciation, and that makes it worthwhile.
Yeah, Matt.
Yeah, definitely. Exactly that. I think the other one as well, like, I got into it because I saw, like, I really enjoyed the contribution part and being part of something bigger. And I liked, the idea of doing open source. And, to that point earlier, I think sometimes you get away from doing it for the love of it, and you start doing it because you feel like you need to do something quickly, and you need to do it because it's a problem. And sometimes your enjoyment disappears from that. But I think if you make sure you focus on what's enjoyable and solve a problem at the same time, kind of most things seem to flow from that. You do good work, work you're proud of that solves a problem potentially for yourself, or it solves a problem for somebody else because you've worked through that. And then you see the reward on the other side. You get people using the tool, people adopting the product. It tells you that someone's getting value from it. They're not doing it because they don't get value from it. So yeah, getting something out in the wild. I think any software engineer can sort of relate to the idea of building something that goes out there in the wild that then actually gets used. Like, how many things do you build in your career that, I can definitely talk about multiple projects where I've spent a few months working on something, and then it either got cut short because, an executive sponsor said, actually, we're doing something else now, put this on hold, and that project never went back. There's one place I went to, 3 of the 4 projects I worked on got shelved multiple months in. So that's really demotivating. Like, I think working on something interesting that doesn't get shipped is in some ways less interesting than working on something less interesting that does get used. So I think, seeing the software go in the wild, working on good stuff, solving real problems, that keeps me going back. And of course, the feedback from people saying, I love it, I want to do more of this, give me some more.
Yeah, I think I'm the same on the solving the real problems. I have absolutely no interest in solving abstract theoretical problems. Like, my husband is crazy keen on board games, and to me that is just like solving a theoretical problem. Like, I can spend all this time like solving this problem at the end. Like, the problem is not solved, right? You haven't made the world a better place. There's nothing easier about, nothing better about the world once you've solved a crossword, right? This is solving an actual problem. And for me, it's still not quite finished. Like, for 10 years, it's been not quite finished. And I actually don't know when I'm going to stop, because clearly it's never going to be quite finished.
Yeah.
I'm going to have to draw a line in the sand at some stage. So what are you most proud of, Ron?
Yeah, that's a good question. I'm not sure what I think. They're building the Rust core. That I did that for maybe over 2 to 3 months. A lot of time in my spare time, but at the same time, I actually learned Rust. I've never used Rust before, and I thought, okay, let's try it. Let's try using Rust. I think there was some people that wanted to do it in Go. They wanted to build a backend in Go, and I really hate. Yeah, Matt was one of them. I really hate Go, and I didn't want to have to support something written in Go. So I thought, no, let me learn Rust. And yeah, I got it eventually. It took a while to get it to a good state. I think it's there now, but the initial bit was the mock server and all the matching logic was in about 2 to 3 months, I think. Now you go back and you look at that code and you're like, whoa, who the hell wrote this? You have no idea what they're doing. That's not a very Rust way of doing things.
But past Ron doesn't exist anymore. It's a different person.
Yeah. Matt?
Yeah. So I feel like in some ways I feel like a fraud in this conversation, because Ron was there at the start and has maintained languages and built the core engine, and you Beth, presumably you'll talk about the Pact broker, and I kind of feel like I joined later and I was like, well, all the heart, those ideas were already there, and I sort of helped establish things. So I think in terms of what I'm most proud of, I think just being able to contribute to the direction of the product and sort of the ecosystem and where it goes, and fulfill that role that sort of hopefully chronic glues people together to do that. And I think that's hopefully has contributed to the ongoing success of Pact and the ecosystem around it. But there's just so many small things, even just sometimes it's just like a small piece of code that goes something. It's like, that was really cool. That was a really nice piece of code, and I really like that. So I don't know if I've got anything singular that's the most proud of. I just think what it's managed to achieve and where it's been is for me very fulfilling. What about you, Beth?
Yeah, I guess the Pact broker would be the if we're talking about actual code bases, that code base is the one I'm most proud of. And just I think just being part of something useful. Like if I had a gravestone that said Beth built useful stuff, that would make me happy, and that's what makes me proud. Yeah. Shall we do we have time for the final question?
I think we have the final one. Yeah, you can ask it, Beth. Go for it.
Where do we think Pact will be in 10 years' time? Ron?
Well, hopefully 10 years' time, all the AIs will be doing all this integration testing. So we won't need Pact at all.
Yeah, you're probably right. Matt?
Yeah, I remember, I don't know if you two remember, but we had a meeting with another past maintainer called Michelle. I think it was at a pub in Melbourne somewhere. And, I remember we're talking through things and we were talking about all ideas and things. And I don't know exactly the words Ron said, but it was something to the effect of, what he's always looking for the idea. What is the next thing that disrupts Pact? What is going to disrupt Pact, right? Because every tool or most tools and products and things will have a life cycle where they kind of peter out and a better idea takes on board. Like you think about, Git, it was just a much better version of CVS and SVN and the things that came before it. And the ideas it was trying to solve were basically the same, but how it did it was just a lot better. And, there will be something that I think will do a better job than Pact. And it'll be very hard for Pact to transform itself into that. So, my hope is, in some ways, a better Pact comes along. But yeah, I think that'll probably happen. I think AI will probably have something to do with it too. What do you reckon, Beth?
You've said it, I think.
Cool. Well, thank you very much, Ron and Beth. We need to wrap this up because we have Sam Newman in a second. But just quickly before we do, just want to put a massive shout out to pretty much everyone or anybody who's contributed in one way, shape, form or another to Pact over the years, including those who just use it, right? I think we build the tool for people using it, and we build the ecosystem. We're part of this community for that one reason. So there's too many people to thank, so we're not going to try and do that here, but I know I can speak on behalf of Ron, Beth, Yusuf, and everybody as part of the maintainer group, that it's really humbling to be part of something so special, and we're just ever so grateful to be able to continue working on Pact together and continuing to address the evolving challenges that comes with building complex software. So yeah, thank you very much. Okay, so thanks, Beth. Thank you, Ron. That was cool.
Okay, thanks guys, that was brilliant. And Matt, thank you for getting to the bottom of Ron's handle. Honestly, I cannot tell you how much pleasure that gives me. Little anecdote, so I worked at DS with Ron, Beth and Matt, and Ron was when I went to move to Sydney, which is I think like 2009, he was actually my first tech lead. It was my first day on the job, and he had this crazy GitHub handle, and I was too scared to ask him what it was, but now you've actually done it in a public forum, so we all know. And I feel this is my key takeaway for today. I'm just going to put that out there. So cool. That was awesome. Any questions? Please post them on the Pactober channel, and we will try and get those answered. So on to our next talk. And this is going to be, I'm delighted to say, it's going to be Sam Newman. He's going to be doing a talk on testing the boundaries. Now, when I was preparing to do this, I was thinking, okay, what's some sort of funny anecdote I can do to introduce Sam? Because now, he's a big hitter now in our industry. If you aren't aware of who he is, he's literally written a book on building microservices, and is a very well-known sort of thought leader. And I kind of realized he's become so famous that he's actually now got stalkers, and that I'm actually the stalker. So bear with me with my little story here. So at some point in the noughties, Sam moved to Sydney, Australia to work for a tech consultancy. And a few years later, obviously, I did the same thing. We both kind of lived, I believe, in the Redfern area, this is starting to sound a little bit spooky. Both supported the Rabbitohs, which is a local NRL team. Could claim because they had an English contingent, but still. In my defence, in the sense of the geopolitics of Australian sport, I'm more an AFL guy, but there you go. And then he moved back to the UK. So what did I have to do? I had to move back to Europe as well, to the UK as well. So there you go. There's more stalking. And I think the last time I met him, I think I'm calling his name out, probably freak him out. I think it was Oslo Airport a few years ago. And so I'm not sure how scared he is about coming online and giving his talk. I hear he has also had COVID really badly. I hope you're feeling better. I have also had COVID. I did not give it to you. I do not believe I was anywhere near you. So please do not blame that one on me. But a little bit about Sam. He wrote literally the book on building microservices. If you haven't read that, seen that, it's I think second edition now, and it's basically the Bible on everything you need to know. He's been a strong advocate for contract-based testing and Pact from back when we were both in Australia and doing a little bit of circuit over there, the conference circuit. And also, what I've always been, when I first saw Sam speak, which I believe was in Sydney, I think it was actually a talk on CMSs, which he probably has hidden really deep far away now. But it was the ability to not only be a really engaging talker, for those who haven't seen him, I'm sure you're going to take that away, but more importantly, was to be able to take a complex problem and really break it down based around the context to sort of really bite-sized chunks that you could really understand. And I think he's done that brilliantly with how his book, and those who have seen him speak about microservices as well. So I'm going to hand over. I think he's going to take control now, and he's going to share his content. And I think you're all going to really enjoy this. So welcome, Sam.
Thanks so much, Elliott. I should probably explain why I support the Rabbitohs, otherwise known as the Bunnies. It wasn't because of the English contingent in the team. I was unaware of that at the time, but I got dragged along by my wife and the people, some of my colleagues. I said, we're going to a game. I thought it'd be good to get to know the people in the office. I just moved to Australia. And and I got on there, and there was a player playing for the other side, a guy called Sonny Bill Williams, and he comes out, the Roosters it was, and some of the ladies we were with were swooning over him. And I found him only conventionally good looking and took an immediate dislike to him and the side he played for, and so therefore started supporting the opposition. And that is entirely why I supported the Bunnies at the time. Obviously now I've come to know that they are obviously morally superior in every way to the Roosters, who are basically, you know, Dick Dastardly in our ongoing feud. But that's it. That's the only reason.
That is a good enough story for me. That is how all rivalries are born, right?
I don't. This feels like a safe enough space to share that in. I continue to support to this day and get up early in the morning to watch them whenever I can. And I'm back in Australia next year. Unfortunately, I think we're missing the start of the season. But not a good season for us. But I should be here to talk about other things. But it feels there is a very strong Australian connection here, despite the fact we've got, you know, obviously a couple of Brits talking right now, but Pact very much started in Australia, coming out of real projects and a lot of conversations that were happening at that time. And so I think it's only fitting that even the Brit guy doing the talk has a very strong connection with Australia, being also married to an Australian. So, you know, there's that. So we're going to be doing a talk today about sort of testing the boundaries. And I want to just explain what this talk's all about, because it's not a talk to explain, oh, this is what consumer-driven contract testing is, because you kind of know that, right? Probably. And if you don't, there are some awesome talks out there to watch. What I want to talk about here is something very straightforward, which is the context in which we use these ideas. So there's a lot of streams of thought happening at the moment, lots of different conversations about. We've got microservices on the architecture side. We've got things on, you know, we've got things around organizational dynamics. So a lot of conversation, discussion about team topologies. And at the same time, we've still got the age-old problem of, oh, I changed something and broke somebody else. So I'm trying to bring together a whole bunch of themes here today in this talk. So we're going to dart around a little bit, but hopefully I'm going to take you on a journey that tries to explain, you know, my mindset around where this fits in the current landscape of software development. And as mentioned, you know, I have written some books in the past, but those are kind of unimportant. You can find out information about those on the internet. I'm easy to find. You type in Sam Newman and then you put in brackets, not the Australian arsehole called Sam Newman, and you close the brackets, because unfortunately I do have an Australian namesake who is a piece of work, I think is what we say here. But we're here to talk about another piece of work at the beginning of the talk, namely certified hottie from history, Frederick Taylor. So Frederick Taylor was the father of Taylorism, which was named in his honor. He was doing some work around the late 1800s, looking at how to optimize the production of various products. If you think about what's happening in the 1800s, we're talking Industrial Revolution type times. Intensive agriculture has resulted in us having lots of spare people, right? We don't need as many people to feed us, which means you have more people for things like standing armies and bureaucracy and politicians and scientists and also manufacturing. And by this, you can see that I've read the first half of Guns, Germs and Steel, didn't quite finish the second half because there's a lot of stuff about agriculture in the middle and I got a bit bored. But this is what's happening, right? So we're getting more people making things, right? Trying to make things in a repeatable way, like pens or motor cars. And in this context, Frederick Taylor comes along and says, look, we've got all this work happening, but there are things that we can do to make things, in his view, better, more efficient. And I'm not going to take you through all of his thoughts because some of them are quite disturbing. But what he, what became Taylorism and then later became known as scientific management, from this, we have some nuggets of wisdom like this. The art of management has been defined as knowing exactly what you want men to do, and then seeing that they do it in the best and cheapest ways. It really stirs the soul, doesn't it? And this next one, a large daily task. Each worker in the organization should have a clearly defined task. So this obviously seems like a really bunch of bad ideas right here, right? So we're talking about, we're putting you in a little silo, we're giving you a little job to do, and you're going to be told how to do that job. And our driver here is about doing that basically as cheap as possible. And, to be fair, in the context in which these conversations were happening and this work was being done, there were lots of improvements to be made. And then it would be wrong of me to say that there were no sort of useful ideas that came out of Taylorism. But of course, a lot of this is being used in the context of manufacturing, where you would sort of try and break any process, any complex process down. The car looks complicated, but the attempt here was to break that down into a series of small steps where you had people doing a very clearly defined role where they didn't have to have too many skills, and they were trained just for that one job. And then that's the way the world worked. And now, obviously, this being such a bunch of really great ideas, we thought, let's copy it when it comes to the world of software. And we see all kinds of siloed mentalities around our software development processes. I mean, we can think, of course, of the classic waterfall process, where we first start off by gathering our requirements. So we would spend sort of 3 to 6 months finding out what we wanted the software to do. Then we would do the system design step, right? And this is where we would spend 3 months drawing a box that was the same shape as all the other boxes we drew on, but it would inexplicably take us about 3 months and still not be the right box. We would then have the developers write the code inside the box, right? Then, of course, we would do the testing. I'm a bit older than I look, but when I started developing, it wasn't assumed that developers had to actually test their code, because, you see, we understood that in our heads, the code worked. So what we would do is we would write the code, and then we would have other people who we would look down on test the code for us, okay? Because, of course, again, we have a defined responsibility. We do a job and we pass it on. So then we have someone who actually does the tests for us. And then once that's all done, we then actually, hopefully, release the code. Now, obviously, at this point, deadlines have slipped a little bit, right? So maybe we would ideally like to have done this in a 6-month period, but this would typically take 1 to 2 years. So I first started as a consultant in 2004, working at ThoughtWorks in the UK at the time. And I would say back then, most of our clients were delivering between every 6 months to every 2 years. And that was pretty normal for the industry. Lots of you might be quite newer to the industry, don't remember 2004. Some of you disturbingly may not have been born then. However, the key thing is that was not unusual back then. Now, of course, times have changed. We would still also forget lots of other things in this process as well, like usability would always come as a surprise. Oh, we want people to actually use the application. And security would also come in right at the last minute because, you know, again, I think security is best thought of afterwards. And we would refer to this process as waterfall, primarily because we had this idea of all of this stuff goes in one direction. There's no feedback loops in this. And you can't go back up a waterfall unless you're a salmon. The other reason it was called waterfall is because when you ride a waterfall, it's highly unpredictable, and it's quite possible that you won't make it to the end. Now, of course, along came Agile. We have the Agile Manifesto, probably one of the least worst manifestos in history, by which I mean it's still really good despite its age. This is 2001, and a bunch of practitioners came together to try and distill down their thoughts about how software development should be done. There were lots of people here coming from different viewpoints and different backgrounds, and there was an awful lot of prior art that was happening at this time. You had things like RUP and DSDM and all these other things, some of which we look at now and seen in hindsight to be a little bit overly heavyweight, even in modern views. But nonetheless, this set of principles that sort of enshrined Agile became a really useful sort of mechanism through which we could change the industry. However, unfortunately, an awful lot of people that looked at the Reactive Manifesto I don't actually think they really looked at the words. And if they looked at the words, they didn't look at the meaning. And so for an awful lot of organizations, what happened was they carried on doing waterfall, but all that happened was rather than it taking them like a couple of years, it took them like multiple months, which, look, to be fair, is still a lot better. Now, there are some principles in the Agile Manifesto that I think is especially important to still bear in mind, especially when we're in a conversation today all about the success of Pact, which is a tool. And so I don't want this to come across as an immediate slam, but one of those first enshrining visions for Agile is the idea of individuals and interactions as more important than processes and tools. Which is not to say that processes and tools are not important, but they are less important than the individuals and the interactions. Now, this is a mantra that I have to spend a lot of time saying. I say it's a lot when I'm working with people building out giant Kubernetes clusters for ease of use. And when they say, have you actually spoken to the people that are going to use them? And they're saying, who are people? What are they? Are they like containers? And there's always a danger when we have it going from a testing tool space that we can often lose sight of the purpose of this. So what I want to talk today is about the purpose of things like consumer-driven contract testing and how things like Pact can fit in that process. And I'm hoping that you'll see that it is actually all about the interactions. So let's look at other silos that we've seen traditionally in our organizational structures. We've seen the silos in terms of responsibilities, and we also see the silos crop up in terms of our architectures. The classic three-tiered architecture, the universal architecture of truth. You could walk into any organization in the world as a non-technical consultant masquerading as being an architect, and you could put out your rubber stamp and say, what we need is our three-tiered architecture: presentation, business, data access. So good they named it 3 times. It's basically what you see over and over again. Part of the reason it's so familiar, I think, is it's easy to categorize code, but it also, we tell lies to ourselves about this architecture, right? We pretend that we haven't put any stored procedures of business behavior in the data access layer. We sort of pretend there's no business logic in the front end, even though, actually sometimes having business logic in the front end is a really good idea, but we can't because of this model, but we do it anyway. But we also kind of align ourselves around this architecture. It's very common to have different people working on different parts of this stack. We have the front-end developers, and you probably all know what the front-end developers look like, right? Because they've got those weird, funky haircuts and tattoos, and they think JavaScript's a real programming language. But they do know where all the best coffee shops are, so they do have some value. And then we have the serious people, the grown-ups, right, that use proper languages, like Java and C#, right? And we talk a lot about things like enterprise integration patterns, and we know about message brokers and the like, and we definitely think that JavaScript is not a very good programming language without ever having actually done any of it or engaged with any of the problems there. But the important thing is we own lots of very big, thick books about technical topics. Some of us have actually read those books. And yes, you will notice I've snuck in a copy there of the 2nd edition of Building Microservices because I'm not an idiot, and this is basically free advertising. This is available from all good and hopefully bad bookshops as well. So, we've always got the serious service developers where we do the services, right? And we have proper languages. And there's also the DBAs, but no one's not entirely sure where the DBAs are. We assume they're still alive because the database is still working, right? But did we see them last year? Or was that pre-pandemic? I think they're downstairs somewhere, right? Now, I'm poking fun here at some of the inherent tribalism that happens within software, which is problematic in extreme. But why does this even happen? Why do we have these kinds of weird siloed architectures with these weird siloed behaviors? What is going on here? Well, I think actually at its heart, a big chunk of this comes back to that looming shadow of Taylorism. Let's come back to observation we saw at the beginning. A large daily task. Each worker in the organization should have a clearly defined task. And this still pervades an awful lot of conventional management theory, even if there are at least lip service attempts to move away from this model. But fundamentally, we still have a tendency in IT projects, although it is changing, to group people based on their core competency. Okay, so we group people together. Front-end developers are with other front-end developers. Back-end developers are with other back-end developers. The DBAs are with other DBAs. And we do this because we want to group people based on their core competency, basically because that's what we've always done. And at the heart of this, there is this myth that you can break down the creation of software to a series of discrete tasks as though you're making, say, a pencil. But software is not a pencil, right? Now, this way we organize ourselves ends up driving these kind of oddly uniform architectures. This is, obviously we can come back here to Conway's law, the observation made by Melvin Conway back in 1968, that organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. What we're basically saying here is that how we organize ourselves, how we communicate with each other ends up driving our system architecture design and also implementation. And this link is being seen over and over again. There's been some great studies showing this out. So fundamentally, if you group people in terms of these discrete competency-based silos, you're going to end up with an architecture which is siloed around those discrete technical disciplines. And this causes a bunch of issues. One of the challenges here is, how do you optimize this process? How do you make it do better, right? From a management theory point of view, what you basically end up doing with this model is optimizing for utilization. So you've got these developers in these different teams, right? And you say, well, how do I make this more efficient, for example? What happens if the front-end developers have got too much work? Well, it's easy, because obviously these are very simple skills that any idiot could use. And that's often how workers are viewed in scientific management as, these aren't highly skilled jobs, are they? Oh, hell no. I mean, you don't have to be highly skilled to work in in building a car, do you? I mean, turns out you do. But anyway, so we've got too much work for the front end. So what do? We just throw more people in, because that's easy, right? It's very easy. You just open the door and just scoop up developers and throw them in. Say, just more front end work. And you crack the whip. Likewise, you've not got enough work going on in the back end, and you say, well, we want to keep our costs down, so we'll just fire some developers, right? That's fine, because again, hiring them again when you need them in like 2 weeks from now is not a problem. Now, beyond the fact that this doesn't work very well in terms of the mechanics and the realities of working in a knowledge worker space like software development, it doesn't work in the manufacturing sector either terribly well. But fundamentally, what we're doing here is we're optimizing for utilization. What we're attempting to do is to make each of those teams 100% utilized. The problem with that model, of course, is that 100% utilization doesn't mean you're actually going fast. And let's examine that, right? Everyone's busy, but we're often busy waiting. How often do you have a problem where you need to take some data out of a database and put it on a screen? And with architectures and sort of these competency-based teams like this, you end up having to coordinate work through multiple teams. So if I've got to make a change in, say, the data layer and the service layer and the UI, simply to put like a new control or a new piece of information on a GUI, then I'm having to coordinate that change across multiple streams of work. This is leading to an awful lot of coordination. And look, we can talk all we want about fancy ideas and highfalutin distributed system architectures, but the reality is that I reckon that 75% of all software development is taking data out of a database and putting it on a screen. And if you're very lucky, you get to take that data off a screen and put it back in the database again. The other 25% is meetings, right? That's our lives. And so these layered architectures didn't seem to be optimized for the kinds of features that we would be creating. And when we were in an environment now where people expect software to be delivered more frequently, they expect new features to come out more frequently, these sorts of ways of working aren't really acceptable anymore, especially if you're building a SaaS-based product. We don't expect things to be, new features to come out once a year. We expect them to come out weekly. So what are the expectations are of society in general are not necessarily lining up to how we're organizing ourselves internally. And fundamentally, these types of architectures do lead to lots more meetings, right? Because you're having to now coordinate work. You're coordinating activities between teams that aren't lined up in terms of what they're working on right now. So if you like being busy waiting around, these architectures are kind of very much for you. So we started trying to improve things, okay? So this is the concept that predates Agile, but came to the fore during Agile, was this idea of, okay, let's actually get teams working together. This is what we call a feature-based team. And the idea here is you create a poly-skilled team that's going to work together to deliver a set of features. So rather than having people broken down in their core competency, which obviously would include, testing being done somewhere else as well. Instead, you'd pull together a team where you would have within that team the skills required to deliver a set of features. So you might have some generalists in there, you might have some specialists in there, but now the dream is that you can own the end-to-end delivery of a feature. This is something that collectively we are working on, and we are going to roll that change out. This also makes it much easier for you to have a sense of purpose. What you're delivering is more closely tied to the external outcomes. The other benefit of this model is that you have an opportunity to grow new skills. Sure, you might be a DBA, But sometimes the right thing to do in this moment to get this feature shipped is not to do some DBA work. Maybe you could help out with some exploratory testing, for example, or help in terms of looking at requirements, or learn how to do some infrastructure automation. This also creates an opportunity where you can grow generalists, but we're kind of moving away from I am a DBA, my job is to write DBA code, to my job is to help ship software, and I work as a team to ship software, to ship features and put them in the hands of people. I think we heard earlier from the Q&A, Beth was talking about the thing that motivates her is working on real practical problems, not theoretical things, or not things that don't ship, right? It's you have a problem, you solve a problem, and you put it in the hands of people. And this is something that is incredibly empowering, rather than being locked away in your silo. So basically, this idea becomes much more of a collective vision. We are working together to get this thing shipped. And creating environments in which it's easier to work together is vital. Kent Beck, in his new book, talks about software design being an exercise in human relationships. Fundamentally, software is, a software-based system is a socio-technical system, right? It's people and technology coming together. It is people that build the software. And only addressing the technical side of this means you're missing more than half of the picture. So finding better ways to work is great. The downside often with the feature-based team model is the fact that we're often working against the architecture, because often these feature-based teams are being applied on top of a pre-existing architecture that wasn't shaped around that organizational structure. Remember, we have this idea of the architecture is driven by the org structure. When you don't have that, you end up with tension. In this situation here, we've got 4 different teams working on different sets of features, but as you can see, they're all working on the same code. They're working across those same layers. And so you can now very easily have situations where one team makes a change that might impact other teams. So I do a change here, but you want to roll out a change there, and that's going to block you. And that means that they can't do their refactoring. So although we would like these teams to be able to come up with the ideas or implement the features and get them out the door, the problem is there's still coordination between these teams needed. Before it was about, okay, can you do this DBA work for us? Now it's about, we all happen to be in the same part of the code base, and so we need to coordinate those changes. Those shared code bases become contention points. So this is kind of a really important thing to understand. If you have loads of different teams working to different schedules, working in the same piece of code, it is a pain to manage. In fact, one of the studies often cited in the context of Conway's Law, studies done by Microsoft, looking at sort of organizational dynamics in the context of their larger code bases. And they found, for example, through a couple of different studies, that areas of code that have a high ownership churn, with a high turnover of users, are much more likely to have defects, for example. Now, obviously, that's extrapolating just from Microsoft's use case. That's a pretty decent case study. You can look up that stuff online. I think I referenced them from the book. So we have this kind of issue. The other problem with feature-based teams as well that shouldn't be overlooked is that typically the vision for feature-based teams was them being a short-lived team. You would pull people together to deliver a set of features. And the challenge with that, of course, is when you have short-lived teams is, there's no incentive for you to make long-term decisions. When we think about something like technical debt, we often see debt as a downside. Debt is useful, right? When you're also the person that has to pay that debt down. So in the short term, we might take on debt to allow us to do something now. But if you've only got a short-term vision for that team, you're not thinking about the impact of the paying that debt down, and you're not going to prioritize paying that debt down. So this becomes a bit of an issue. So we need to shift this model, and that's what's been happening. People think, well, we like this idea, owning delivery functionality end to end. The short-lived nature isn't great, and we also have this problem with everyone contending and fighting in the same part of the code base. And so what we've been looking at is, over the last sort of 10, 15 years, how do we shift the architecture here? How do we give these teams full ownership of their software? And this is where microservices fit in really neatly. I work with clients all over the world who are working on different types of problems, but the single most common reason why the larger organizations are moving to microservices has got nothing to do with They've got large scale in terms of amount of traffic or data, because enterprises rarely have scale issues. It's not because of latest technology. It is simply, and this, they want more organizational autonomy. They're big companies with lots of developers, and it's nowhere near as efficient as they want it to be. And so they want to move to a model where they have a lot more organizational autonomy. Now, obviously, the results of that, if you do it properly, is you end up with losing a whole chunk of middle management bureaucracy, which isn't something that people always realize at the time, but that's a separate discussion. So what we're aiming for here is a model now where we have teams that own services. So we have that, this is my service, I own it. So now I can think about the short-term and the long-term vision for this software. But I also can deploy that when I want. So now we have a model where we have teams being able to own changes end-to-end, being poly-skilled, and with a microservice model, being able to deploy those changes independently. Now, what's unwritten here is that I think this also should apply to the user interface. Wherever possible, I think user interfaces can and should also be decomposed along these lines. There are sometimes technical constraints that might make that more challenging, but I think that should be the norm, not the exception. Unfortunately, we took a wrong turn about 15 years ago and started thinking that single-page apps were a good idea. I'm not saying they're not a good idea in some ways, but they were fundamentally designed to be monolithic in nature. And it's only really been in the last 5 years or so people have realized, oh, can you break apart user interfaces? Because, fundamentally the people that designed single-page app frameworks didn't understand how the web worked, and so didn't know about things like websites and had never built user interfaces in the past. I say this having known some of the people that built the single-page app frameworks we all now use. We are now realizing that having giant monolithic user interfaces is not necessarily a good idea. And it's like, oh, well, let's retrofit in some ideas around this concept called modularization, which comes from the mid-1960s. But anyway, I digress. So we're now into a world where we're looking for teams that can drastically reduce the amount of coordination they need to do when releasing software. The inventory team are able to implement features and roll those changes out without having to coordinate with other teams. This in turn means you improve release frequency. When we're releasing things independently, we are reducing the batch size of a release. The release itself is smaller in scope. Smaller scope releases are easier to make happen. They're less likely to go wrong. Saying does go wrong, they are easier to fix. If you reduce the batch size of your release, you will be able to release more frequently. This is not agile. That's just good old-fashioned lean thinking right there. And also we have evidence from things like the State of DevOps report, as outlined in the book Accelerate, that organizations which release more frequently also have lower regression rates and lower rates of rollback. So there's all good reasons why we should be doing this. This also then opens up the model where the teams that own these services can potentially to own the full life cycle of these services. The whole you build it, you run it, you ship it model. That's not right for everybody, but this at least is now something that gets opened up with this shift in thinking. So this is all great. But one of the problems here, of course, is the changes that we make. This team here, the inventory team, is deploying a brand new version of their inventory microservice, right? Seems like a good idea, but we see these inbound arrows. Right? Now, these arrows represent dependencies. This team here on the top left depends on the team providing this inventory functionality, because with a service-based architecture, we have this interesting, not paradoxes in a way, but maybe inherent contradiction. Because on the one hand, we want these things to be independent. We want to be able to change them independently to get all the good stuff we get. But on the other hand, fundamentally, our systems only exist because microservices collaborate with one another. So these dependencies here from the team in the top left on our inventory service give us pause for thought. I'm going to change that microservice. Do I still meet the expectations that my consumers have? Do I still do what they want me to do? Because if I roll out a new version of my microservice and it causes some sort of issue, well, what does that mean? Well, it potentially could mean a production outage. So a lot of focus then becomes into how do we catch these kinds of changes? When we are about to release, do we know if we are releasing software that is going to still work in a production environment? Now, I have a whole chapter in my book which explains why end-to-end tests are a great fix for this problem until they're a terrible fix for this problem, right? There's a journey you go on with them. So I'm not going to go through that again. So instead, I'm really going to jump to kind of how we're trying to solve these problems without using end-to-end tests. Well, the first thing, of course, in this situation is just don't break contracts, right? So, start from a viewpoint, which is we aren't going to change our APIs or our endpoints or our message formats in incompatible ways. We are going to look to expand. Adding new things should not break your clients. Adding new optional fields should not break your clients. If I get a customer payload back from a service and you've added on some new information, that should be fine. Now, if it's not fine, I would call into question the technology you're using for your communication and serialization protocols, or how you've written the clients, right? So that's this. We'll get it. You can look up the tolerant reader pattern if you want to know more. So from a mindset point of view, understanding that maintaining backwards compatibility in a microservice architecture is really essential. Otherwise, you don't get the ability to change things in a nice and easy fashion. So your APIs and things, you need to look at expansion changes rather than contraction. Contraction is where you start breaking compatibility. But we also need to create an environment where we can catch and eliminate the accidental breakages that occur. So assuming we've done our best to not break APIs, how would we know if we were going to do it? Now, I think broadly speaking, I break contract breakages down into two categories. I'm not sure if this is kind of other people's models as well, but I like to separate these two out. So I think one is more obvious way to fix than the other. And so I think we can split our breaking changes down into either being structural breakages or being semantic breakages. So to give you an idea of what I mean by structural breakage, this is where the shape of the information flowing changes in a way which is clearly not backwards compatible. So I might send you a payload, and I go from sending you, I send you a payload, and I've removed information you expect. Structurally, the stuff I'm sending you is now different. You might have a method that I've called over maybe it's an RPC interface, and I'm calling a method over a network, and it's a method that used to take 2 required parameters. It now takes a 3rd required parameter. Right, that again is a structural breakage that should be pretty easy to pick up. And this is typically where I would use schemas. And I'll get into a bit more what I mean by an explicit schema. And schemas can pick those things up quite nicely. Then we've got the more tricky problem, which is the semantic breakage. So I go and say to a service and say, can you give me a shipping label for this package? And what comes back is a PDF that contains the shipping label that I can then, give to a customer to print off or whatever else. But then you change that API, and rather than it being a shipping label that comes back, what actually comes back in that PDF is a picture of your dog. Now, structurally, I can't see the difference between those two things. Semantically, one of them is good and one of them is very much not good. And so over time, I've done a bit of a 180 on this, right? I used to hate schemas. I now absolutely see their value. And so for me, this is why I like thinking about both testing and schemas together, because I think this way you kind of do the easy stuff with the schemas and you do the difficult stuff with the tests where you have that power. So I am really and I think part of the reason I was so anti-schema for a long time, and again, anti-explicit schema for a long time, is because I lived through the horror of SOAP, the Simple Object Access Protocol. Never has the word simple been less well used, where you have an enforced use of something like the WSDL schema, for example, right, which is you have to use as part of SOAP. And in fact, any RPC mechanism, pretty much Java RMI aside, it mandates a user-defined schema. So some technology protocols enforce a schema. The benefits of schemas are basically that you get that ability to pick up structural breakages in a pretty quick and easy way. They're not foolproof in that regard, and some tech is better than others. But if I change the interface for a service and I have to update the schema to reflect that change, there are tools out there that can look at 2 versions of the schema and pick up the easy stuff. You had 2 fields that were required. You have added a 3rd field, which is required. That is a backwards incompatible change. I know that's not all changes and that's not all breaking changes, but that's a bunch of the easy stuff that should be easy to pick up. And so we've got things like, the Kafka schema registry, for example. So this is an optional thing you can run alongside Kafka. So you can upload the schemas for your message formats, and it supports Avro, proto buffers. It might support JSON schema. I'm not sure. I think it does. And it will tell you if they're backwards compatible or not. Now, the great thing about that is, as a developer, that's feedback I can get at my laptop before I even check in. For me, the analogy here with the use of schemas and explicit schemas is data static typing to dynamic typing. So the statically typed language, your types are fixed at compiler time. So Java, C#, for example. What that means is, if I try and call a method on an object that doesn't define that method, the compiler errors. And so I have to fix that as a compilation error. With a dynamically typed language, the types are fixed at runtime. That means I don't know until I actually run the program whether or not that method is actually going to exist. So that means that when I'm trying to verify my programs, whether they work, part of my test burden with dynamically typed languages is there for typing issues. Now, I love using dynamically typed languages. That's the stuff I use mostly for now with my own code and things like that. However, I see the value in that fast feedback of static typing, especially when the impacts of getting it wrong are so great. And so around those service interfaces, I think there's a lot to be said for using things like, Protolog for gRPC endpoints, or using OpenAPI diff if you're that way inclined. I said the word explicit schemas here a lot. And lots of people saying, well, I don't have a schema. I just send JSON over HTTP. Well, you always have a schema. The question is whether or not your schema is explicit or implicit. When you send just plain old JSON over HTTP, beyond the fact that, it's probably not REST, the recipient of that JSON payload has expectations as to what that payload is going to look like. They expect certain things to be there. They expect a name field to contain a string type, an address field to contain a nested JSON collection, or whatever it might be. The difference is, when you send it, you don't know what those expectations are. That is the schema to a great extent, being a subset of the overall contract. So, I think both consumer-driven contract testing and schemas are about making what is implicit explicit, and making it explicit in a way that we can verify if we've broken those expectations. And I think we can and should do schemas for the same light as we do, say, contract testing. So that then leaves us with the contract testing to solve the really difficult hard problems here, which are, okay, are the semantics of this service what I expect? So fundamentally here, the places where these things become useful, most useful, is then in the interface between teams. When we're communicating between ourselves, we are having conversations about how things should work. Now, actually, when this stuff works, you actually reduce the amount of coordination and communication that happens. And what you're left with is the communication and coordination that should be happening. The conversations between the team in the top left and the team in the bottom right regarding the interactions between their services. It is right that the top left team, who own returns and shipping, do have conversations with the inventory team. Partly to say, well, I'd like your service to do this, but also to agree things like SLOs. I've long been a proponent in thinking of service design in a consumer-first mindset. One of the big issues around microservices is ensuring that they can be changed without causing compatibility issues. One of the big ideas here is to use this concept called information hiding. You basically hide information behind your service boundary. The idea being anything you hide inside your service boundary can be changed safely and easily. This is another cutting-edge idea. That's this one coming from 1971. The problem often, though, when you come into creating a microservice is, well, how do I know what you should hide? And often the reason people are struggling with this decision is because they're thinking inside out, not outside in. So we have a situation, this can often occur when you're creating a service ahead of other people needing it, or in an environment where you're not that bothered about finding out who your consumers are. So I'm building a service, I know I've got some data in a database. I know I'm going to have some consumers at some point, but I'm not sure who they are or what they want. So in the absence of actually knowing who my consumers are, I'm just going to guess. What's the safest thing for me to do to cover all bases? because remember, I probably don't have to come back and rework this later on. Well, what I'm going to do is just grab whatever I've got in my database and stick it on the API. Okay, it's sort of one-to-one mapping. My data model becomes my API, suddenly you didn't know anything better. And now basically your consumers are now coupled to your internal data model via a really inefficient wrapper on top of SQL. And in this sort of situation, people say, oh yeah, but we don't know who our consumers are, so we don't know, well, we could do anything else. I'm like, well, if you don't know who your consumers are, how can you decide things like what acceptable uptime you've got, or how much load you're going to handle? You can't at the same time talk to me about SLOs and not know who your consumers are. That doesn't work. So there are all kinds of downsides with this model, right? The first thing is we're basically not hiding the database. This is information hiding in the same way as having your fields being private in your objects, but putting public getters and setters on it. Distressingly, there are now multiple products on the market that will instantaneously give you a GraphQL API just by mapping your database straight to GraphQL. And at that point, I'm like, why do that, right? If you're just going to integrate the database, talk straight to the database, because at least then you'll be using an appropriate query language. And also, OData is a thing. Anyway, and the other issue with this model is beyond the fact we've now basically coupled our external API to our internal implementation. Do we think that is a nice and easy to use endpoint? Do we think it's going to be pleasant to use? What we end up with is an API that models our internal implementation detail, not an API that is built and designed to make our service easy to use. And look, microservices exist to be called. Their job is to be called by other things or to call other things, and that's it. They're either being called by other microservices or user interfaces and the like. You need to treat your microservice endpoints like a user interface. If you were going to create a graphical user interface for your customers, you would go and sketch it out. You'd have a conversation with them. You'd tweak it based on their feedback. You'd iterate it a few times because you want your users to be happy, don't you? Because otherwise you'll go out of business. But in a microservices architecture, we are creating endpoints that other people will have to consume. We are creating user interfaces. These are internal users, and they're called developers. So in this situation where you create a graphical user interface that maybe a customer doesn't like, you don't necessarily know who that customer is. They might be effectively a faceless entity to you. There's a disconnect between you and them. It's not nice, but it happens. But when you create a microservice with a really crappy API, just because you couldn't be bothered to have a chat with the people that are going to use it, you're creating a bad user interface that's going to be used by people who know who you are and know where you live. Doesn't seem to make much sense to me, because many of them have a very special set of skills and they will find you. Instead, we can solve a bunch of these problems by inverting our thinking. Start by thinking consumer first. I mean, consumer-driven contracts go back to the mid-2000s, where we were trying to formalize having conversations between consumers and producers. And the original stuff was like, not testing, it was like, let's actually talk about what you want and design the API together. It was co-design activities. So start from the viewpoint of going, it's not an amorphous consumer, it's a specific consumer or a group of specific consumers. What do they want? What do they need? Because not only do you then come up with an API which is nice and easy for them to use, right? Making their lives better. But this is also how you establish exactly what you need to expose and no more. So if you're struggling with concepts like information hiding, go outside in, only expose what's needed, nothing else. This will really result in the interfaces you're designing, the endpoints being smaller in scope and more stable. And the less stuff going on in your API, the easier maintaining backwards compatibility is. So when we've had this conversation, and it should be a conversation, right? We have had a conversation, we've designed it together. Things like the schemas and the contracts tests that we come up with, they're a representation of that discussion. They're a representation of the relationship between those teams. And that relationship will be ongoing. So where things like contract testing fit into me is a living representation of that agreement, but also an ongoing part of the dialogue we would need to have. I think it can sometimes be a mistake because of how good Pact is, that you don't actually have to have conversations with the people, they just kind of come up with new expectations. I think we can be better than that necessarily, but at the very least, something being checked in and owned by another team, they know who we are. Software design is fundamentally an exercise in human relationships. And I think if you really want this lovely new vision of autonomous teams that can, go fast, we need to be explicit about our boundaries and have the right kinds of conversations with the people around us. It starts, though, with those individuals and interactions, supported by the best tools and technology out there to make it work. But it does all need to start with a conversation. That's me, because I figured it might be nice to have time for questions. And I knew I was going to be quite ranty this morning, so I thought I'd better leave some extra time in case I was going to get censored. But yeah, I thought I'd throw the floor open to questions.
Cool, thanks. I mean, my first takeaway is Frederick Taylor as a hottie is going to be my second key takeaway for the day. That was not on my bucket list for the day. But
it's the smouldering good looks, it's not twinkle in his eye. Yeah.
I was thinking of the relationship with Taylor Swift there, like a Swiftie kind of world, but yes. We did have a few. So the first one is, I guess in your role, firstly, awesome talk as usual, by the way. Really hope people enjoyed that. I think, the ability to take a lot of very complicated concepts, as I said at the beginning, and reduce them down is always brilliant. But in your experience, obviously, previously consultants thought works are now sort of independently. What sort of things, capabilities are you looking for and characteristics in teams when you firstly sort of start suggesting they maybe start looking at microservices, and B, also when they should start looking at Pact? And from my own personal experience, just give this is sometimes people find out I occasionally contribute to Pact Python or whatever, and they say, oh, we should use it straight away, and I kind of like back off and like, hey, you haven't done these things. So I was just curious to hear what your thoughts are. When's the right time to sort of, that next step? Because I don't think it's always the first step, as it were, in that journey.
Yeah, I mean, so if we talk specifically about microservices, I describe it as an architecture of last resort, which is microservices are a means to an end. You've got a problem that you can't solve with your current architecture. Try solving it in all the simple ways first, and then you can look at microservices. So if someone comes to me and says, should we do it? I'm like, what else have you tried? Because microservices as a concept are never the low-hanging fruit. I think then the next step on beyond that is talking generically about any situation where you have interfaces between separate components. This could be between microservices within an organization. This could be between APIs with external parties or whatever else. Then that's the next question, is the interface situation. Obviously, microservices drastically increase the number of explicit interface points that aren't covered by compilers and the like. And so then the conversation comes around the contract testing stuff. I think the challenge around contract testing is that it does require ongoing interaction from both parties. It's a bit of a high trust, but no, it's an ongoing conversation and an ongoing dialogue for, I think, it to work well. And I think if you're creating a public-facing API that's going to be used by 20,000 people, you're not going to have 20,000 people constructing those consumer contracts for you. You might decide to use those yourself as part of your verification process, but that for me is not the kind of the immediate use case. So it feels to me that that interface, that use of consumer-driven contracts is something that works in a situation where you do have two parties that want to work together. Otherwise, if I were as a producer saying, I want to do consumer-driven contracts, but none of my consumers are on board, I'm like, well, this is not going to go anywhere. And so that's kind of it. Now, I think that's kind of why I've started talking a bit more about using explicit schemas, because I feel that people doing nothing, they're doing end-to-end tests, and that's it. And so then if I start talking about the consumer-driven contract idea, which does imply a shift in thinking and a shift in interaction models in terms of your agreements, that's almost a cultural change that needs to happen. And that can take time. And so that is a tough sell for a lot of organizations where they think the people calling their service are, smelly poo-poo heads or whatever it might be, right? So like, actually for me, sometimes, have you tried looking at using schemas? Not as a way of saying that's better than configuring contract testing, but basically as a way of starting to get slightly more formal and slightly more grown up about that service design. I also think getting them to have conversations about SLOs is also helpful. A lot of focusing on SLO conversations are about things like uptime and speed and latency, the non-functionals. But that incorporated into that should also be an understanding about things like how much backwards compatibility can I expect? If you do need to bring in a breaking change, how much time will I have? What kind of verification can you do? Because if you're operating in an environment where I want you to write tests for my service, that's benefit both of us, that should be part of those conversations. And like an SLO is effectively a concrete artifact of that conversation, every bit as an explicit schema or a contract test is. So yeah, there's a lot of grown-upness that needs to happen, I think, around that. And I'm not going to lie, when I've run in some organizations and they've just got 2 or 3 services or whatever, I'm not going to push them away from end-to-end tests at the beginning. I'm going to tell them this is not going to work long-term. But if it's working for them at the moment, I'm going to tell them about the things that are going to start going wrong and let them know to look out for them, and then tell them when that happens, this is what we're going to go do. But yeah, it requires a degree of maturity that I just don't always see early on.
Yep. It's a good point about the public API. I've seen that personally a lot as well, where, and this, I think it's an interesting section with traditional QA and engineers with something like Pact, right? Is it an engineering tool or is it a tester tool? And the truth is it's a little bit of both, I feel. And sometimes, this is my personal experience on the public API, and I know Matt Bettenmore will probably agree with this. If you've got a public API with a version with public consumers and 10,000 consumers, you're not gonna, it's not gonna work contract testing. And if you want to use it as a testing tool, that's for your internal teams. There's probably a pathway for that, but the schema, I think, completely makes sense for me in that sense. The other sort of follow on from that, I've got a Beth question in a minute, which is because I love UIs, but the pain of failures around the end-to-end testing. That's a really good point as well. Because I agree as well, like there's this seductive path to start end-to-end testing and that sort of journey. What are the sort of breakpoints for you, and how do you get teams to start thinking about okay, you need to do the next thing when you're working with them?
I mean, there's the issue is, I mean, it's again, Beth used one of my favorite phrases in the early Q&A talking about the boiling frog. I think unfortunately a lot of the time tests become the boiling frog. What happens is that the cost of creating and maintaining your end-to-end test increases, but the value decreases. And that's not something you're going to see overnight. So for me, often the easiest way to kind of break that out and make the conversation, shift the conversation to a different level, is to talk about coming back to why microservices, right? So you want microservices because you want to release things independently, deploy and release things independently. Okay, but your end-to-end tests are bridging across teams. Who owns those end-to-end tests? Who's responsible for those end-to-end tests? That whole workflow ends up limiting your ability to be independent, putting aside all the other challenges with end-to-end tests. So actually often approaching it from the point of view of you want end-to-end tests because you want to be autonomous, but so you want microservices because you want to be autonomous, but your use of end-to-end test is undermining that goal. So it's often easier at that point to have that breakpoint conversation, which is, what do we do about that? And so an obvious thing is to start doing is saying, okay, well, we're going to move to a model where we only do kind of large scope integration testing within a team, right? We break away from a multi-team end-to-end tests, which often requires external teams doing testing, which you also lose a dysfunction. Let's move to saying, look, let's just try and get each team doing end-to-end testing. And then you suddenly find that those teams don't feel like they need to end-to-end testing, right? But I find it's often that circuit breaker. I mean, you can, of course, do the toil stuff. You can actually track the time spent on these things. And I think the other challenge, again, is the boiling frog, is that an awful lot of the kinds of failures you're going to see are only going to happen once you're in prod. There's a wider variety of weird things that are going to go on that become increasingly difficult for you to reproduce in your end-to-end tests anyway. And so you're going to have to get good at that, at doing more stuff in production anyway. So it's also a little bit about saying, we are going to, we're not just going to rip those end-to-end tests away. We're going to ramp down our effort and ramp up our efforts in other places, and you'll get a better outcome from that. But that organizational dynamics one, I think, tends to be most common one I can use to snap that conversation into a new vein.
Yeah, I agree. The social technical side of it is a challenge. We've got JB Rainsberger on later, and I know he's going to talk about some of the maths behind why these things don't scale. I have to ask Beth's question because we all know she loves JavaScript and front-end development. So she wants to know how, so you mentioned the front-end monoliths and the SPAs and the world that's taken over. How do you go about recommending to teams to break that down? What sort of techniques and technologies are you seeing that are being successful in that space?
I think the fundamental challenge is often when you start having that conversation, they've already got an existing UI. And there are UIs that are amenable to decomposition, and there are UI designs which are not amenable to decomposition. So that is often just a hard break. So if they've got something which can be componentized to an extent, you can see that rationally it's doable, I'm open to it. So with single page app tank, you're basically saying, we're going to do single page apps, but we're actually going to do the micro front end thing, which is basically we're going to have multiple single page apps in a single page, which are just further breaking the brain there. So that is the model, right? For people that have already ill-advisedly gone down the single page app route because you hate the web and everything that Tim Berners-Lee stands for, you horrible people. Right, so if you've done that and you're not building a web page or a website, you're in that world. So there you're looking at the micro front end stuff. So there you'd have a container, basically application. You're putting in the multiple single page app components. And effectively what you end up doing normally is creating like a virtual message broker, almost a message bus inside the browser for allow communication between the panes. Now, the good thing about that is it means that you can actually, you're not sort of locked into one single page app framework, and you can actually do you could even say it's all React, but I can have different versions of React in the same browser pane, which is kind of cool. But the downside is that can be a bit of a heavy lift. And as I say, some UI designs are not created in such a way to allow for that, because you might have to tweak the design to do it. I would think native applications are a bit of a different fish. Like if you're building native iOS and Android applications, I'm not as close to what you need to do in that space. So I'm probably going to just demur at that point and say, I plead the fifth on that one. Because normally I just email Stu Gladow in Australia and he tells me what to say. And then I say, I think this, but it's really just what Stu told me.
Yeah, don't get me started on mobile apps. I'd have no idea either. Yes, I know there's some extra challenges just by the nature of the build. I know some new technologies, I know there's React Native and Dart and stuff. I do think allow you to modularize a little bit better, but I think some of those you end up with it. Yeah, by the nature of the beast, and you've also got the idea of an app store as well, which adds an extra layer of complexity, right, when you deploy into those. We had a great comment from Frank Kilcommins. Coaching consumers through the must-ignore pattern and being tolerant is also a journey, which I think you probably echo. And then you mentioned RPC frameworks being problematic. I do remember the dark days of SOAP, trying to explain that to a young developer today, that the joys of SOAP is it's a nightmare. Would you mind elaborating this? How does something like gRPC fit into this, basically? Like RPC is a slightly different model. I think they're schema-driven. I assume you're probably going to touch on that a little bit. I know we have a lot of internal questions in the maintainers chat about what we do with different sort of technologies like this.
Yeah. I mean, firstly, gRPC is a really good RPC implementation. Like if you want to do RPC, it's the best widely used and widely supported RPC implementation out there, in my opinion. There's some benefits just because of the fundamental nature of the technology, right? JSON is rubbish for sending around between computers. It's an awful format, and it's bad for humans, right? It's bad for the planet. Whales die when you use JSON. So there's a benefit to using binary protocols. And we have to recognize, of course, that with a microservice architecture, we get very chatty communication. A single call coming in from the outside world could kick off a fan of calls internally. So this also then leads us to situations where we might want different communication protocols for, what we traditionally call our north-south versus our east-west communication. So gRPC's found a bit of a nice space inside organizations because inherently it's quite fast. It was built to run on top of, TLS and makes very good use of HTTP as well. So all your normal routing stuff still applies. So with gRPC, you have to define a schema. So you have to say, this is the way I'm going to communicate. These are my methods. These are my messages. These are my types. And then you basically will generate clients from that. Now, some people see that as a limitation, And I see the point, but there is support in the protocol for backwards optional fields. I mean, I'm almost biased because I also used the precursors of all this stuff inside Google, and it works really, really well. One of the benefits I like of the schema is really, really good inter-language interoperability and also client-side code generation for client-side stubs. That, I think, is a massive benefit. An awful lot of organizations are doing schemaless REST. They're sending JSON over HTTP, and then they don't have to redo all the work for clients to write their codes. They create client libraries, and the client libraries end up becoming massive points of coupling. So I like just solving that problem, moving away from it all. It is not REST, right? It is a REST, but most people doing REST are not doing REST. So let's get that one out of the way.
Yes.
So I think it's great, and I think it's and I think schema format is much simpler and leaner because it's a schema. The schema is always there from the beginning. It's not like with the Open API format where they're sort of having to kind of come up with a schema definition afterwards, which is a bit more of a messy space.
Yeah, very good basis sometimes, yeah. And the last thing, and I'll let you go, is this is for our budding authors out there. Writing a book, especially one as influential as building microservice, is a noble feat, great language. When did you decide that was something you needed to do, and any advice for budding authors in the audience?
I liked writing. I always liked writing. And so that's the key thing. I've met a lot of people that want to write a book, but they don't actually want to write a book. They want to have written a book. And so I eased up to it, right? I contributed a chapter to a book. I wrote lots of blog posts. I wrote lots of things in like huge volumes internally inside ThoughtWorks. I've never not enjoyed the process of actually sitting down to write. And honestly, that's it. So I think if you want to write a book, start by writing something and by finding out, do you like writing? Because ultimately you might be one of those people that's got some great stuff to share, but writing isn't for you. Don't be dispirited by that. Find the other thing you want to do instead. I just enjoy the process. And that's that. I mean, there's no magic answer. If you want to write a book, don't start by writing a book, write a blog post, do a Substack, something. Just get in the habit of writing, learning, finding your voice is really important. I was quite lucky by the time I wrote my book, I sort of found the way to put me on the page. So that's it. Just you write a book by getting good at writing. You don't have to get good at writing. Just get to the point where you know how to write in a way that you enjoy. But yeah. Awesome.
That's great advice. Thank you for your time today. Brilliant talk. Good to catch up with you again. I'll try not to be so stalkerish next time. And hopefully bunnies go a bit better next year. They went all right this year, so we'll see.
Oh, we'll get there. We'll get there. All right. Well, good luck for the rest of the day, everybody. And thanks so much for having me.
Cheers. Thank you, Sam. Bye.
Bye-bye.
Okay. So next up, I am going to introduce my co-host today. He's been sitting in the background waiting for his moment, and now he's here. Yusuf. He is basically, for those on the Slack channels will know who he is. He's basically described himself as a community shepherd for Pact, and I think that's a great way of describing himself. His background is a tester turned quality coach turned developer advocate, now with SmartBear. So he is going to introduce the Fireside Chat. I'm not going to introduce the other speakers, though I'm pretty pumped about the speakers that we have. So I'll let him do that, and I'll let him take over from here. Okay, hi, Yusuf.
Awesome. Thank you very much, Elliott. Hello and welcome, and happy Pactober, everyone. I'm really thrilled to be here to celebrate 10 years of Pact. So I won't bore you with details about me. I'm going to introduce our fantastic speakers. So we've got Baz Dijkstra, we've got Dave Farley, and Lewis Prescott. I will just run you through our agenda quickly for today. So we've got an hour with this wonderful panel. So we'll spend 5 minutes. We'll just let the team introduce themselves. And then we've kind of got 4 topics for discussion. We'll talk about the origins, both of the panel's career and kind of how they got into contract testing. some kind of tips around adoption. We'll see if we can eke out some words of wisdom from our panel as well, and then we'll kind of take a look at what the future of testing and quality and software development look like. And then hopefully we will be brimming with questions. So we'll open it up to the floor to everyone, and we'll also invite our existing members who are here to throw in some questions. So without further ado, I will drop my slides and I will throw over to, we'll pick it at random, we'll go for Lewis.
Hello.
Hello.
Yes, I'm Lewis. I'm currently a quality engineering lead at Elliott, which is a healthcare startup based out of London. Been involved in contract testing quite a while now, getting involved with Pact and sharing my knowledge all over the place. So yeah, great to be here, and obviously a privilege to be around the people that you've got here today.
Awesome. Thanks so much, Lewis. Dave, thank you for joining us. It's an absolute pleasure to have you here. I was just watching yourself on YouTube with Seb Rose, who introed us at the start of Pactober. So yeah, please tell us a little bit about yourself.
Sure. My name is Dave Farley. I'm these days I'm an independent consultant and loudmouth on YouTube, I suppose. I run a YouTube channel about software engineering, testing of all kinds, and so on. And I'm an author of several books, including Continuous Delivery Book and Modern Software Engineering.
Awesome, incredible. And last but not least, we've got the wonderful Baz. Could we tell the audience a little bit about yourself?
Sure. First of all, thank you for having me, Saf. It's good to see you. My name is Bas Dijkstra, so you almost didn't butcher my last name. Well done.
I tried.
Awesome. Sorry. I'm a bit like Dave, but then also not like Dave. I'm an independent consultant, trainer in most things automation these days, but with a specific focus on API integration and definitely also contract testing. So I do some consulting, I do some training, I do some blogging here and there, I do some speaking, a little bit of everything really. And yeah, I'm very, like the others, I'm very excited to be here. And congratulations on making it 10 years.
I know, I'm absolutely thrilled. Thank you. I joined, I think the Pact kind of open source community back in 2017. So much like Matt, I feel like I'm riding on the coattails of others, but I think I suppose you probably all found in your career that we're forever standing on the shoulders of giants, those before us who've kind of tread great steps. So let's, without further ado, let's drop into our questions. So first topic I've got is origins. So I'd like to learn a little bit maybe about when did you first kind of hear about contract testing, or maybe when did it form part of your kind of quality strategy? And yeah, kind of, I know you guys all talk about it, but yeah, when was that kind of light bulb moment in your career? Feel free, anyone, to do this.
In all honesty, I'm not sure if that light bulb has switched on yet. What I do see is that I sort of try, by doing it a lot and talking about it a lot and reading about it a lot, my story continuously evolves, and I find myself every day, I find myself being a little bit less bad at explaining what contract testing is and the kinds of problems that it tries to solve. And I was thinking, in preparation for this, I was thinking about where did I first heard about Pact, and I honestly can't remember. So I think I've heard about the term of contract testing a long while ago, and then I don't really understand this. And then Pact came in. I think I got into touch with Matt at some point, and we did a bit of back and forth, and started reading up on what is this new thing, what is this Pact thing, what's the problems that it's trying to address, and I sort of kind of slowly grew into that.
So like as your test strategy, you look at kind of test automation and kind of the full strategy? Was there a certain point where you weaved it in, or
yeah? So I talk and train and consult quite a bit on so I try to avoid UIs wherever I can. It's unfortunately a lot of my clients say, oh no, UIs are fantastic, we should all do all of our automation through the UI. I talked and I've been doing a lot around API testing and automation for a while, and it sort of kind of was like a natural progression. So once our systems get larger and we have more components that communicate with one another, it's always the question that question of, are all of these individual components able to talk to one another, is going to get harder and harder and harder to answer. That's it. And I ran into that before I was introduced to Pact, and that's was well, here's Pact, and this is a technique, contract testing supported by tools, Pact, and later on also Pact Flow, that tries to address that problem. So it's sort of kind of weaved itself into the story and into the things that I've been doing.
Fantastic. And Dave, I know that you've been in the software development industry. You've got lots of experience under your belt. You talk about, the full continuous delivery life cycle, and I suppose contract testing plays some part of that in that for you. So where did it kind of come onto your radar?
Sure. So I like lots of these things. I've been practicing versions of continuous delivery for a very, very long time, longer than it was called continuous delivery. And so as a result of like much of the practice that I talk about, it's really pragmatic. The way that I came across contract testing is because I had problems that I couldn't solve, and I needed some way of defending boundaries of my system that I didn't know how to do. So my first exposure to contract testing was rolling our own contract tests. So I was building a large financial exchange, and we wanted to isolate the exchange so we could test the rest of the exchange and leave the external integration points alone and not involve those in the testing. So we built some contract tests for those points that we ran. The first time that I came across Pact was, I remember fairly clearly, I think it was at a conference, and it was at a conference not very long after Pact was new, and somebody was presenting the ideas of this new framework for organizing contract testing. And so I was kind of intrigued by that and interested in that. I confess, hand on heart, I've never actually used Pact in a project because of my experience of rolling my own and doing my own thing.
Yeah.
Although I think it's a remarkably important tool and useful. And I was at another conference recently, and I saw Seb talking about the Pact broker and the problem of all of the different dimensions of testing, how you test multiple versions and all of the different kinds, and the way in which Pact can help with those sorts of problems. And that's a real world problem that I face all of the time in consultancy. So although I've not actually used it personally on my own projects, partly because I haven't done any projects of that kind for a long time myself, I've advised people and helped people use it and introduced it to quite a lot of different places now.
Yeah, no, I think that's a very good point though, Dave, because it's a technique and a mindset shift. So I think Sam was talking about the mindset, and you can apply those techniques without Pact. You can apply behavior-driven development without using Gherkin, and it's quite easy to roll your own, but then you sometimes have to deal with, now that you have these contracts, how do you associate those contracts with your versions of your software? And the matrix, I think, was definitely the kind of shining jewel in the crown of Pact. Right, thanks for that. I will pass over to Lewis and just find out where he first kind of, so Lewis has worked as a QA lead, so I think he's had lots of seen firsthand some of the challenges of integrating multiple services, and at some point Pact or contract testing came onto your radar, and I actually met you through common friends in the Ministry of Testing. So yeah, I'd love to hear about how it kind of came to be.
Yeah, so like I got introduced to it like probably 5-6 years ago from a CTO that I worked with, and I was doing API testing at the time using JavaScript, Supertest, like traditional integration testing. And I couldn't, like, when he introduced me the concept, I just couldn't get my head around the fact that, okay, but we've built the service, like why we have like consumers, we already have these tests which test the integration. So it wasn't until a couple of years later when I worked for ASOS where we had lots of large distributed teams working on each of their siloed microservices, where I really saw the value of it. And that's where I started to implement Pact. And yeah, understanding that it's the communication. And I think like Sam touched on this in his talk a lot, and like it's a lot of what I talk about as well, is like it's those communication starters. It's those points where you have that human aspect where you need this tool, like Pat comes in and goes, look, this is what I'm talking about. This is the programming language. And then Pact gives you that human aspect of this is how I start the conversation. So yeah, that was where I really like started to click for me. It was like, okay, I've got all these distributed teams and like I have no idea what their service does. I have no idea how they use our service. That's when I started to really see the value of it.
Awesome.
I'd like to add something to that, if I may.
Yeah, please.
I think Lewis makes an important point. I'm an old school OO programmer, and one of the light bulb moments for object orientation for me was I was building this system and I suddenly realized that all of the pieces were really simple, and the cleverness of the system was in the conversation between the pieces. It was the messages that mattered, the conversations. And I think that one of the things it's easy, you know, if we talk about tools like Pact and focus on those, they're great tools, but tools aren't enough. And this is part of an architectural approach where you're dividing up a system and the conversations between the pieces matter in a different way to the implementation of the pieces, certainly at the level of testing, but also in terms of the way in which we structure bigger systems, I think. And I think that's an interesting point.
Yeah, I think I remember, so I came from a like kind of traditional QA background, and I remember doing manual testing, and we just had this kind of on-prem application and everything was there in a box really for me. And when we moved to distributed systems, we still had to kind of do the same thing, but just now there was all these different components. So I was still trying to ultimately prove the same kind of business value as being performed by the system, but now I had like loads of different moving parts, and actually those moving parts were now they were potentially prone to failure, but they were all being developed by different teams. And what we were finding was when there was issues between these computers, there were frictions between the teams, and there didn't need to be that friction between the teams because we were all just trying to deliver something awesome, or hopefully. Something that, so not just around contract testing, but it was Sam's talk kind of, he talked about the Agile Manifesto. And I think when I first came into computing was around 2007. So I think around the time the Agile Manifesto came out and Ian Fowler was talking about contract testing as kind of a service evolution pattern, not necessarily around kind of APIs and microservices, but just people were beginning to talk about these kind of great techniques from experiences they'd had in the past. And when you kind of saw and it resonated with you, some of these things, it was a challenge, or I definitely found it a challenge, say, as a tester in my role, really to champion that across my organization and really find, you know, the right people, or to speak the right language to the right people in order to really improve our delivery quality. So not just like contract testing, but say all these great practices we talk about, continuous integration and continuous delivery and kind of all these different points of quality checking at different points of the SDLC. Like, how do you guys work with teams and organizations to elicit that kind of organizational change or shift in mindset towards maybe delivering a better product? Like, someone's coming to you, like they've got this really bad system and they're like, we need to build something new, and maybe you need to just talk to them and find out what the problem is.
I'm happy to go ahead.
Go ahead. So what you're saying, like, is the problem. You've got to solve a problem. And I think, like, as we all know, like, the end-to-end tests don't scale, the integration tests don't scale. And so that's how I always present it, how I always try and adopt it is, okay, this is the problem that we have, and this is a solution to that problem. So yeah, approaching it from that scaling aspect of, okay, we need our tests to run faster, and we need that feedback faster. So how are we going to achieve that? And coming with the problem is the approach that I take.
Is there and I'm just going to take over, Seth, and ask a question to Lewis.
Yeah, go for it. Honestly, everyone feel free.
No, because what I'm seeing, so the people I work with, so I haven't done a whole lot of consulting around so it's mainly speaking and training. What I found and what I've seen and what I've read is there's still, unfortunately, a big difference in how well and how easily people who identify themselves as developers understand that are able to implement contract testing compared to the people who identify themselves as testers. I'm just curious about how do you deal with that? Because and especially if we talk about Pact, so about the consumer-driven kind, it's if I run workshops on content, try to get people to get that light bulb in their head, go on, but this is contract testing, this is what it does, and this is the kind of problem that it tries to solve. It's bloody difficult to get that light bulb to go on with the average tester, whereas with the average developer it's much easier. So I was just wondering how you deal with that. Do you tell the story in a different way, or do you say, well, just don't bother with those testers and go straight to the developers? Or
I actually remember a time when, so kind of, I was a manual tester and I moved into doing automation testing, and I had some kind of technical experience from not using it in my actual career, but just kind of hobbyist programming. And I used to talk about pushing tests down the stack, and doing more unit tests, but really I wasn't writing unit tests, and I was in a siloed team. So we were in a test team, and there was a development team. So we weren't seeing we were seeing a finished product and testing it from the outside in. And we weren't really seeing what the testers were doing, the developers were doing, and what kind of tests they were covering. So I had this kind of narrow view as to what they were covering in their unit tests. So we had integration tests that we were running, and we run into failures with just various things that were going wrong. And as we began to talk to the developers and kind of look at what they were doing, we were seeing that there was an overlap in what the kind of testing we were performing. So they weren't just doing this kind of idea of, this unit testing wasn't just this big blob. It wasn't just like they were testing pure functions. They were like component style integration testing. So they were testing where there's a bounded context. So where a service or a component is going to talk to another component. And that's where they were like mocking out, a representation of another service. And by mocking out this representation of another service, they could get really quick feedback. They could run their tests repeatably and reliably. And that was something that as a tester, I wasn't able to do in my suite. So I had all these different variables that were changing. And I was like, well, we're kind of doing we're doing the same kind of testing again. And we could actually, these failures that we're finding in the integration testing, we can find them in like lower down in the stack. So actually, if we can get them lower down in the stack, I can make my testing job easier, because most of the, like, if I differentiated the idea of quality checking versus testing, I want these computers to do this kind of checking, this automated low-level stuff. And then I want to be able to use my testing brain, my gray matter, to kind of talk to people and make sure we're developing the right thing. So it's a challenge I find in siloed teams. You really need to be able to know your developer.
No, so it's because we're essentially trying to solve an integration testing, an end-to-end testing problem at the unit testing level, almost. What I find with a lot of a not insignificant subset of the testing orders is that they, as soon as you say, well, we're going to shift this to way early in development, try and address these issues almost at the unit testing level. So, oh, that's what the developers do. We don't do that. When unfortunately it is all about common, and it would be so beneficial if testers would be able to have these conversations with the developers and the rest of the team about what is the problem that we're trying to solve, and then what's the most efficient way. And I know that's one of the reasons that bidirectional contract testing was born, basically, to solve that problem. And I find in my workshop, I typically start talking about consumer-driven contract testing, and you see people, you just see the gears grinding in their heads, and then say, well, and this is a different approach, and that's the bidirectional approach. Oh, but I can do that. It's and almost without exception. So I was just wondering for you, Lewis, Dave, any insights on that? Any tips for this poor chap, maybe on?
I don't know about tips, but I can talk about the way that I approach that kind of thing. And
I'd love to.
And let me just philosophize for a brief moment, because I think that something significant has happened through the course of this century, rather than software development up until it. I think we've had a transition, and I think that we are at the birth of a genuine first-class engineering discipline for software development. I think that we now know what works better than other ways of doing things. And a lot of what we're talking about is part of that. Things like continuous integration, test-driven development, contract testing. These are the tools that allow us to do some of these things. Now, for me, the way in which I kind of solve problems, whether in consultancy or in software development, is by applying some of these, what I think of as foundational principles. One of the foundational principles, two principles that matter deeply to me, I think, is first of all, I think that we should redefine what quality in software means to mean one thing. It's our ability to change the software. If your software is easy to change, it's high quality. If it's hard to change, it's low quality. And I know there's lots of other things that matter other than only that, but you don't get those other things unless you can change the software.
Agreed.
The only other alternative to being able to change the software is to get everything perfectly right first time, and nobody can do that in modern systems. So quality is the absolute goal. The other idea that I think is foundational in this context is the idea of working more experimentally. And part of working more experimentally is to control the variables. So we need to, in order to do better engineering, we've got to exert more control over the variables. So when we're talking about things like contract testing is a deep player in our ability to control the variables. We can isolate whole parts of the system and get rid of worrying about those things. And through architecture and design and contract testing, we can make what the piece that we're working on easy to change without worrying about the impact in other areas of the system. So this stuff really matters. And then practically, in terms of how we get people to start to buy into this, I think it's about. I think somebody said, I can't remember if it was Lewis or Yusuf, but somebody said something about optimizing to increase the feedback or faster feedback. And I think that's deeply part of it. So our aim is to be able to spot when we make a change, whether that's good or not. And that's part of keeping our software easy to change. And we get that feedback by having things like contract tests. So we can potentially, there are other ways, alternatives to it, but that's one of the tools in our toolbox to achieve that really fast feedback. So I tend to talk about the principles like this to my clients, but I also say practically, your goal is to get to optimize for fast feedback, and I put some limits on it. I say, if we on commit in a deployment pipeline, I want feedback in under 5 minutes.
Yeah.
So how you achieve that, from the commit stage in under 5 minutes, depends on the software. Sometimes contract testing is part of that, sometimes it's not. But for bigger systems, more distributed systems, contract testing is a fantastic tool to make that easier to achieve. So that's the way that I tend to approach it. I tend to have what I think of as a logical arguments as to how you build up these things and maximize these deeper principles that I think our disciplines built upon, and then you take advantage of those, and that they help you to choose the tools in the context in which you're working.
Agreed.
Any advice just for the general testing community who still, I love that answer, by the way, Dave, I wholeheartedly agree, but there's a lot of people I know in the testing community who say, well, that's really something that developers should take care of, and that we're happy to do some kind of acceptance testing and see if it all works according to the end user expectation specifications and see if there are any problems there.
What if I was to say something contentious? So a tester's job isn't to find bugs, and a tester's merit isn't determined by the code that they write, like the testing code that they write. So you employ developers, they're great at writing code. They're great at solving, well, first and foremost, they should be great at solving problems. And if those problems warrant code, then they should write code. Yeah. But ideally, great problem solvers will try and think smart, work harder, work smarter, not harder. So if you can not code yourself, not get into worrying about building some software that's going to be complex to change in the future, don't do it. The other thing is so I remember going into a client site in a consultancy. I had this imposter syndrome. I was the only tester in a team of 8 developers, and I'd never had this kind of disparity before. I was like, it used to be siloed tester. I'm going to have all this weight on my shoulders trying to be the purveyor of gatekeeper of quality. And then I realized that's not my role. And Dave, you said about principles, right? And getting to know your team and getting to know what ticks for them is really great, because once you know what works for other people, you can talk to them in the way that they want to be talked to. So I was like, right, I've got all these things that I care about in testing. Let's just sit down with these 8 developers and find out what they care about testing. And I found out that there was different types of testing I hadn't thought of before, like mutation testing, for example, at a unit testing level. So we all shared all this stuff on the board, and then we just had a chat about it. And alongside this, there was kind of this idea that the teams would own their software through to deployment. So they would deploy their own software, and because they're deploying their own software, they would have to write, they didn't want to test it every time when it was deployed in production. So they put these little tests and stuff in place, and they'd always be using this little, I used to think they had this little mini SAP in their head that was just always kind of just telling them this board that we had, they just had these kind of principles of things we care about. And then because everyone had these as principles, it was really easy at review time to say, hey, we haven't done X, Y, and Z, so we're going to do them because that's our definition of done. So it's difficult.
It's I think you're right. It is difficult, but the other part of this is that this idea of optimizing for feedback is deeper than it seems. I think when you start to really dig into it, and what you said resonated with me. I was kind of nodding and smiling as you were speaking about. It's not the job of a tester to gatekeep access to production. If you're employing your testers in that way, in my view, you're doing it wrong. So, there's a fairly famous quote from Edward Deming, from the grandfather of lean manufacturing, who said, "You can't inspect quality into a product; you have to build it in." And so, in order for the job, depending on what labels you apply to people, whether you call people QA or testers or whatever, I think the job in both cases is to up the level of quality in the products that we build. And you don't do that by doing lots of testing, as you described in your kind of your anti-pattern case earlier on. After the software is finished, you do it as part of building it. So you want really fast feedback, and the way that you get that is you get the testing right up and front and center. So I'm a BDD person. So I want specifications more than tests. And if somebody finds a bug after I've built it, that's a failure on my part. It's not somebody else's job to find the bugs. It's my job as a member of a software development team, and that takes all different kinds of skills. So you need these cross-functional teams. You need testing thinking up front and center as part of the development process, and engaged with the process of actually building the software, and people looking at it from a testing point of view as other people maybe are constructing that software and it's growing. You don't wait until the end. You don't build mini waterfalls of testing after the feature's finished, for example, in my view.
You can test quality into a product. And something that you mentioned there about specifications, I think is really pertinent, I think, in the API space, and leads quite nicely into something Baz was saying about bidirectional, and also what Sam was saying about schema checking. So there's lots of great kind of mechanisms now for describing different services depending on the transport protocols. So we'll take one, for example, say Open API. So, and we now kind of might suggest that if you're creating a RESTful service, you might want to document it in Open API, and therefore you can benefit from kind of a human readable aspect in a nice UI, or a machine readable aspect that computers can use for various purposes. So there's a open source tool that was built by Atlassian to solve some of their problems with their Pact verifications. So rather than replaying their Pacts, their consumer contracts against a live provider, they would replay them against this specification, this Open API specification. So many people like this feature. It's kind of been packaged up into the bidirectional feature in Pact, but a lot of people are beginning to sometimes they think that that's kind of enough for their testing. So for me, I think there's two, when we're talking about contract testing, maybe it's not so, maybe people conflate that with just consumer driven contract testing. So we're looking at
definitely
consumer, what the consumer needs from a provider. But actually there's this idea of, well, if we're going to present this specification that says this is what my service will do, we've kind of got a job in checking that that presentation of that specification is actually correct compared to our implementation. So that's kind of the provider. You could have this provider drift. So you ideally want a contract between that specification and your provider implementation. And then wider than that, could we argue that every test is a contract?
I know I'm talking too much, but I think there's something important there that I'd like to get to. as we're moving forwards with growing this engineering discipline and being able to specify these things that we want, but really what we're talking about here is this is what measurement is for software. The tests, the specifications that we build are measuring the software. So one of the things that contract testing does is it allows us to insert a measurement point into a point in the system where we can measure more accurately and more precisely. And one of the things with measurement in other engineering disciplines is you have ideas of tolerances, and I think that what we're talking about here, when we're talking about these multi-direction contract tests, is really the tolerances. We want to be able to again protect our ability to maintain the contracts that we hold between different parts of the system, and we want some kind of tolerance, allow some levels of drift between them. And what the contracts do is that they assert that we are within our tolerance, and if we move outside, something breaks, and we know that we can't put those pieces together. And I think that's quite an important idea, and I like to keep putting it back to these engineering ideas, because I think there's something profound about those that really matters in terms of us being able to do a better job. And when we think in those ways, we can sometimes come up with newer and different ideas. And there's this boundary between testing, always to me in its engineering sense as the measurement, and the architectures that it drives us towards as a result. I think contract testing has changed some of the ways in which some people think about how to partition systems for the better, in good ways, I think.
I would 100% agree. For me, it fundamentally changed the way that I think about developing software. And I was actually fortunate in the team where we kind of moved from the on-prem to Lambdas and serverless. And I actually had the good fortune of being able to partake in developing rather than testing, and I actually got to feel firsthand some of the pains of developing software, and actually how some of the bugs and defects that you find fundamentally change the way that you approach developing software. Do you think that teams need to feel the pain of their systems not talking to each other, or the pain of their systems not working in production, to really value that the time and effort and energy they're putting into testing? Because some people are like, just build something, put it into production, fail fast. But what does that actually mean?
I think that's one way of learning. I think if again we sort of think as engineering as a an organizing principle, it's not the best way of learning, because it means that everybody's got to make all of the mistakes. And it'd be nice to be able to build on the shoulders of giants and not make some of the mistakes that people previously did. At the moment, we're still at the stage where pretty much everybody has to make all of the mistakes. And I would rather that as a discipline we grew up a bit and started to get to, let's just agree, some of these deeper principles and just rely on them a little bit more, and then we can do more. We can start going further. The mistake, one of the things that always surprises me, there's a book written in 1970 called The Mythical Man Month. If you just take the bits where it talks about the actual computer systems and read it, it's all completely true about what's software development today. If you just ignore the actual details of the systems that they're building. So we're still making the same mistakes as we were making in 1970. So let's find new ways to make mistakes and find ways of improving practice. And I think that's what I mean when I say that we are doing some of that. I think that some of the lessons that we have learned, including tools like contract testing, are starting to move the game on, but it's slow. And I hope that we can get past everybody making the same mistakes over and over again, and that being the only way to learn.
Yeah, that resonates for me. Right, so we've got some great questions that have come in from our audience in the time being. I think it might lead on to what you talk about. So great to talk about all these different that we should kind of think about these guiding principles. So I assume our guests are all familiar with the testing pyramid. Yeah. Do you think that's still a a helpful concept that guides you, or are there any other paradigms that kind of you're using at the moment?
I'm happy to say that, but I'd let Lewis go first, because I know you've got something to say about that.
Yeah, so I definitely still use it as a guide, but yeah, I definitely don't use it in the pyramid perspective. I think like technology's moved on a long way, and we can get fast feedback from our higher level tests, and yeah, we think about testing from a different way, like than we did before. So I think like we've definitely moved on from the pyramid, but I think it's still a good guide. And like when you think about contract testing, we talk about it falling in line just in between that integration and that unit layer. So it's a good guide to say, okay, contract testing kind of slides nicely into there, but it's definitely not a pyramid. Like I like to use the kind of Spotify honeycomb where you have lots of integration tests, and I think that's where we've talked a lot about the challenges of communication, and I think that's heavily where we should have our tests, right? And then you start to think about how fast can we get that feedback, and at what layers. But yeah, I definitely think focusing more on the communication layer is key, and adds a lot more value than having loads of unit tests.
Well, I can really only say, well, that's very, very much in line with what I think about that thing. By the way, it's always been a triangle. So let's just get that out of the way first. It's not a pyramid. It has always been a triangle. But anyway, it's for me, it's both way past its sell date and still a very good conversation starter about just what you said, Lewis. It is, we as testers, we are in the business of uncovering and presenting information about quality and potential problems around our software. And the most important, the only important thing is that how can I get that information in as efficient a way as possible? That's what we are. And that triangle model helps me introduce the different ways and the different layers and the different scopes of doing tests, performing tests, writing tests, running tests in, and the only advice I typically give is this: just don't do something, don't try and uncover that information with an end-to-end test or an integration test if you can get it at a unit test level. And I think contract testing is just one of these. So I've been in this not nearly as long as you, Dave, but I've been in this in this business for some 17 years now, and this is contract testing thing is one of the very, very few truly, I was going to say new, but it's not even new, but the truly different approaches to trying to find an answer to that question of, are there any problems with our software? So by actually breaking down that big puzzle, that big question of, are all of these different services and components and layers and whatever in our system able to communicate with one another? And by breaking that down into smaller steps that are more efficient to execute. So.
Okay, so I'm very, very sorry to disagree with the rest of our lovely panel. I am something of a natural heretic, and this is one of my heresies. I'm not a fan of the testing pyramid or triangle, as Bas correctly points out. There's something that people find helpful there. I concede that. But I think it's the wrong shape, and I think it's the wrong piece of advice. And at the very best, it's a retrospective view. Are you going to not write a really helpful acceptance test because you've got too many of those?
Right.
That seems like a really stupid idea to me.
So first, I definitely don't disagree. So I'm pretty sure what you're going to be saying is not as contradictory or to what I was thinking or trying to say. So
Sure.
I think
sorry, you're not as much of a heretic as you think you. At least, well, not in this particular.
Not here. Cool.
No, not here right now.
Maybe,
cool.
Elliott.
We've got time left. So
Elliott's posted up. All models are wrong. Some are useful.
Indeed, absolutely, and you know, one of my personal principles is that I always starting out assume that I'm wrong. So I'm not really nervous about being a heretic. I'm okay if people disagree with me. That's not a problem. I don't assume that I'm necessarily right, but I want to say what it is that I like to express what it is that I think about these things. And I don't think it's right. The best testing that I have ever seen on any project wasn't pyramid shaped, wasn't triangular, it was more like an hourglass. We had loads of unit tests, tens of thousands, and we had loads of acceptance tests because we were doing test-driven development, and we were using acceptance tests to drive executable specifications for every single feature. So we had tens of thousands of those. We had tens of thousands of unit tests. And we had almost no integration tests because the acceptance tests did the job of those. We also had a whole bunch of contract tests for isolating and faking out external third parties. So that was, that looked nothing like a testing pyramid. But on that project, we were 13 months and 5 days after our first release into production before anybody found a bug. I mean, what do you want? Our job is to build good software. It's not to build good, perfect pyramids or triangles of tests. So it might be a useful tool. I've never found it very informative. I don't believe, so I think it overrepresents what I think of integration tests, because I think integration tests largely are tactical. They're not part of my default test strategy. My default test strategy is built on acceptance tests, executable specifications of the behavior of the whole system, the releasable unit of software, and unit tests. And I would have loads of unit tests. I'm a test-driven developer, so I'm going to have lots of unit tests, and that's but I'm also going to have lots of acceptance tests. So I'm not a big fan of the testing pyramid at all, and I've railed against it a few times because I think it can lead people into to misguided views about what to test. My view is that I want to find a way of testing everything. These are our measurements. These are how we tell that our software is good. So I want to test everything. And depending on the nature of the project or the system or the team or whatever, that might change what I choose as part of the testing strategy. But it's got built on, is my software releasable? And does it do what I think it does? That's fundamentally, those are the driving principles. How
do you define testing everything? Because one of the things I keep finding myself saying is, instead of trying to test everything, why don't we start trying to test as little as we can get away with?
So we've actually just had a few comments in on our YouTube channel. One from Anto at Treatwell, who was actually in our last community session. So he said, and it's quite nice, it rolls into around the principles. So and Anto said, personally, especially in a world of distributed architecture, I prefer these principles to the pyramid. So favor small and pre-deployment tests over large and post-deployment tests. Favor in-memory representations of stateful dependencies over deployed instances. And I think this one's really will point to your point, is test just at the right level for what you want to verify. So you'll get loads of different feedback from these different levels. So if I'm writing a little CLI application, before I start writing some tests, I'm probably going to run it end to end and get that really rich feedback just to see that it works. But as I start building that system up, that complexity of change will, exponentially grow if I don't put those kind of tests in a different layer. So finding that balance of testing the right amount at the right level. One thing I use is testing quadrants, because I got into the idea of testing being everyone's responsibility. So the testing quadrants just allow me to think about things I use to guide my development and things I use to evaluate my product, and then also try and think about them from two different aspects. So kind of the developer facing aspect of it, so what it costs my developers to change it, and then the business kind of facing the impact, what's the cost of change for the business and the impact on users. Right, so I think we might have a couple more questions.
I just while you're looking at those, I just wanted to touch on the testing everything. There's a good example. So I think this is right about strategically. It's about picking the levels at which you test things. I like to pick codes out to use as kind of counter examples, bad examples sometimes. And there's a code from one of the well-known open source continuous integration systems. That there's a test that I found there that's about, I don't know, about 150 lines of test in one badly named test. And when you kind of pick it apart and figure out what it's doing, it's starting up the entire application, and it's doing that in order to tell that it doesn't proceed if it's got localhost in the URL in the configuration. You can do that in a unit test. So you should do that in the unit test, and that's all you need to do. You don't have to test everything in all of the levels. So finding the levels is right and important, I think. And then I think that part of the reason that Bas is alluding to in terms of not wanting to test everything is that there's a focus often from, if you're thinking about this from a testing point of view rather than a specification point of view, there's a difference. If I'm trying to specify what I want the software to do at every level in my testing, that automatically limits how many tests I need in order to express that. So this is behavior-driven development, but kind of fractal. It's at all levels of testing, and I think that's the best way to organize tests on the whole. And so nearly all of my tests are sort of BDD shaped. They're expressing what the system needs to do without saying anything, as little as humanly possible as I can achieve, without saying anything about how the system actually works.
Yeah,
and then
as soon as you have to start updating those tests, as you update your system, start you marking your own homework.
So I think that's one of the techniques to kind of sensibly manage the scale of the tests that you're having, but still test all of the behaviors that you can think of.
Incredible. Right, we've only got 3 minutes left, so not sure if we're going to have time for any more questions, so maybe I'll just leave with that's been incredibly insightful. I talked to you guys for hours, but how can the rest of the world keep in contact with each of you if they want to either continue the conversation or hear about some of your learnings? So I'll go with Lewis first, my friend.
Yeah, you can always reach out to me at pactman.co.uk or on the Dying X platform, or just reach out to me on LinkedIn, or in the Pact Slack, of course.
And you can also, if you want to hear more from Bas and Lewis or other contract testing and just general awesome people within the quality and testing community, give a listen to Lewis's podcast. So over to you, Bas.
I've been not on you can't find me probably, or at least not me, on that platform formerly known as Twitter.
I tried to find you earlier today, but I couldn't.
No, there's good reason. LinkedIn works nicely. Pact Slack too, or through my own site on testautomation.com.
Awesome. And if people want to check out, they can. I think there's plenty of YouTube videos or courses they can catch up online for yourself.
Yes, yeah, absolutely.
Awesome. Yeah, so be sure to check out On Test Automation. And Dave, you've got loads of stuff in store. What's happening?
So I am currently on the platform with that nobody wants to name, Dave Farley 77. Don't know for how much longer, but I'm there at the moment. I'm on Mastodon as well at Tech Social. Same handle. And if you go to YouTube and search for continuous delivery, you'll find my channel. There's lots of stuff there, including videos specifically on contract testing and on the role of testers and QA.
Fantastic. And if we have any potential budding speakers in the audience, I'm sure they can all get in touch with you and potentially connect. Fantastic. Well, thank you so much for your time, gentlemen. It's been an absolute pleasure. Thank you for all your work you've done within the just testing community and development community, sharing good practices and principles. And I hope to be here in another 10 years, and hopefully that AI hasn't taken over the world. Right.
Thank you, sir.
Well,
Thanks so much for having us.
And I'll hand back to the lovely Elliott.
Thank you, Sip. That was awesome. Thanks, Lewis, Baz, and Dave. And actually, for Dave, I've been slowly starting to digest your engineering room YouTube videos. So it's on my to-do list to get through more of those. I saw the Kelsey Hotel one recently, so it's appreciated sharing that content. So moving on, we actually have a quick 15-minute break. I know some of us need a quick comfort break, a cup of tea, or maybe you're in not English climate, so you're probably not going to have tea, maybe a coffee for our American friends. And then we will be back 1 o'clock British summer time, 15 minutes for wherever you are. And we will proceed, I believe, with some Pact updates. So yeah, we'll call it there. Give you a quick, it's 14 minutes now, so I'll stop talking and put myself on mute. And I think I'll just share my screen until then. Okay, see you then. Okay, welcome back. Hopefully you've got your refreshments and ready to go. I think we are actually just going to go through for the last two sessions and probably not have another break. So hopefully that's okay. It's not too much longer now. It's just under 2 hours. So the next session, we're going to start with Matt. Basically, what we want to do is go through and have a little bit of a look forward. So we kind of had a bit of a celebration in the morning about how Pact came into being and a bit of the history. So hopefully that was a interesting, like the origins, I guess, but a bit more looking forward. And also we want to get people who are helping to contribute and maintain all the different libraries within the Pact ecosystem an opportunity to express where they're at and where we're going and all that sort of stuff, and hopefully generate a little bit of interest. Pact's quite an unusual open source initiative in itself, in the fact that because it has to work with so many libraries, it requires lots of libraries to work with all of those languages. So there's always opportunities to get involved and help out. So there's a little bit of that, but also primarily just to get us looking forward, and also for you to get to meet some of the people behind the scenes who do all the work, who you see on Slack and in the GitHub commits and PRs and that sort of stuff. So with that, I think I'm going to hand over to Matt.
Awesome. Thank you, Elliott. Yes, we are going to look forward in this session, and we're going to talk about some Pact updates. I'm going to spend the first half an hour-ish taking us through some of the strategy, the roadmap, the vision, and the key initiatives that are actually underway at the moment to address those. Then I'll hand over to Yusuf, who's going to take us through kind of a whirlwind of all the kinds of things going on across the community and some of our new maintainers. That's what that slide should have said. I should have talked to that slide. Okay, so stepping back a little bit, as I mentioned at the outset, Pact was created to solve the burgeoning problem of caused by microservices and predominantly RESTful architectures. So we're going to return to the topic and the relevance of contract testing and Pact in 2023 and beyond. So we look back before, Pact solved a problem back then. Is it still relevant now? And if so, how do we keep it relevant? So we've sort of mentioned this before, that myself and Ron and Beth and Elliott and Yusuf, and we actually all have worked through various consultancies before. And I was lucky enough to work at a bunch of Australia's largest and well-known organizations and their distributed architectures, and I got to see them evolve. There's been, of course, huge amounts of technological change since the days where SOAP dominated the technological landscape that inspired Ian's article. And in my relatively small career, about 20 years or so, I've worked from Corba, SOAP, REST, microservices, the rise of public cloud, IoT, event sourcing, event streaming, data pipelines, serverless architectures, you name it, lots of things. And I found in many of these architectures and contexts that contract testing, at least the idea of contracts, is still relevant, and would look to introduce that into places that really we thought benefit was to be had there, could solve a problem. However, in the course of these kinds of rollouts, I'd often be on the receiving end of some form of snarky comment, sometimes from another competing consultancy maybe, but it kind of had this argument that sort of goes this way. If we just used insert some new technology, then we wouldn't need contract testing. Well, is this statement true? Is REST really the problem? And could we save ourselves the trouble of having to worry about contract tests and implement them and maintain them by using a superior approach to communication? Well, I did this talk a while back, and there's a whole bunch of slides I could follow here where I take you through these kind of really interesting arguments and technological reasons. But the short answer is no, it's total BS. These problems still exist. And in fact, some of them, and the reason why I asked this question of Sam about gRPC, in some ways they're worse than REST. They give you guarantees that you think you get, and actually in practice, they don't. It doesn't work like that way. And it really shouldn't be any surprise to you. If you watch Seb's talk, in the opening of Pactober Fest last week, you would have heard him discuss implicit and explicit contracts, and then talked about how, like, a language called IFL that was built in the 1980s had the concept of design by contract built into it. And so these concepts are at least as old as me, because I was born in the same year, as fate would have it, that language was created. Obviously, Sam talked about this as well in his structural and semantic breaking changes. So anyway, in these investigations, I ended up creating a bunch of blog posts and talks. And as I said, Sam's done a good job of breaking this down, that schemas can't solve our problem. But even without going into these technical arguments, you can also arrive at the same answer by just talking to people that use these technologies. So theory is great, but what happens in practice is kind of more interesting when it comes to engineering practices. I always like to bring problems and where we're headed with things back to customer statements or user statements or use cases, if you will. Here's a customer quote. This is from Pactflow, but that I really think helps set the scene for what engineering leaders face today. You can have a quick read for that quote while I'm talking, but one of the benefits of running a SaaS platform around Pact is the increased visibility we get into customer problems and customer contacts. They're more likely to reach out to you and give you a lot more information and complain about features that don't exist yet and all these kinds of things. So you get really good insight into these kinds of problems and what they're looking to be, what problems are looking to be solved and what solutions maybe will apply. Anyway, what you should be able to take away from this quote is that it's a very chaotic environment. This guy looks after about 40 teams in a very large banking institution, and he's just looking for some way to bring process and control to the situation. And of course, they're smart people here. Like they're not idiots. These are engineers. They're probably reasonably well trained. But it's just a complex adaptive system, and it's a very difficult problem to solve. In any case, if GraphQL solved the problem, well, he wouldn't be coming to me saying they have this problem. If Kafka solved the problem, they wouldn't be coming to me saying Kafka's the problem. And I have some really interesting quotes from a global payments company that used gRPC, mentioned in those previous blogs and videos, of some really disastrous consequences of some of the ways that those technologies work. So anyway, if it sounds like your architecture or your company or organization, or you're feeling some of these pains, you're not alone. Research from both Smart Bear State of Quality backs this up, and we'll talk about another one in just a minute. But microservices adoption is tipped to continue to grow, with 61% of respondents stating that they expect huge growth from microservices in the next year. And also the majority of API practitioners operate in a multi-protocol landscape, so more than one protocol. So I think it was 81% were working in one or more, and 60% about said they work in 3 or more. Interestingly, we get this very similar finding from Postman's State of Report, but one of the additional things it adds is internal integration is becoming both a challenge and a focus. So I think organizations are starting to recognize the value in opening up new use cases internally. So kind of similar to what they did with data. I think APIs are starting to continually grow internally to build better internal use cases, cross-pollination, all these kinds of things. Last year, that didn't even count in the top 3 of the problems. So it just goes to show that it's really still growing, and there's a lot going on beneath the tip of what is the public-facing, user interface or API. Excuse me. The third one is, while microservices aren't new, they're at least 10 years old now, and many lessons have been learned. There's this kind of very long tail set of challenges that we're starting to face as an industry. I won't go through all those bullet points there, but the one thing that I find really fascinating in this report is that mature API organizations are the ones feeling the pain. That sounds really counterintuitive, doesn't it? Like, if you're mature at building APIs, wouldn't you be better and wouldn't you have less problems? And I think part of it is spawning from this proliferation of microservices and issues from changes. And hopefully we all understand, we're all, here probably could have heard of Pact before. Maybe we've seen some of our videos and our content. A lot of the problem is these old ways of building and testing systems that just don't scale with such highly distributed systems. And so I think that's what explains that particular problem. In any case, all of this is to say that technology is getting more complicated. It's more distributed. There's more technologies. There's more languages. There's more frameworks. There's cloud. There's all these things. And also, hopefully, as we've learned through today's discussions, through Sam's chat, through the Fireside Chat, is that contract testing transcends specific languages and technologies, right? It's a concept that's been around for eons, or at least contracts have. And as we've learned, it doesn't just go away magically. There's more than just a technological answer here. It also enables collaboration and teams to work together. So I think we still think contract testing makes sense. So the question is then, does that mean Pact is relevant? And how is it going to keep up with these evolving needs? So this is where I'd like to talk to you briefly about some of the strategy work we've done this year and in the past that it's really about targeting some of those problems we talked about, as well as some of the internal challenges that, again, we kind of talked about earlier, that just come with dealing with not only a large ecosystem, but something that's being used by a lot of people. You can't just make drastic changes to a tool that's used by a lot of people without considering the side effects of those and starting to think about what value is there and being able to roll that out in a way that's controlled, right? It's just something that we have to deal with. And so in any case, we got the contributor community together early this year, and we ran a series of mostly asynchronous and offline strategy workshops to discuss the future of Pact, to get alignment and really a shared understanding of the challenges that we face as a community that we need to focus our attention on to address. As you can sort of see in the slide, the intent is not for you to see the detail of this because it's just a lot. It's just going to show you that there was a lot of work and effort that went into this. The first one is, the process we went through, is to first start to articulate a bit of a vision. So what do we see Pact looking like in 1 year and a 5-year horizon? So kind of what do we need to solve now to get us through, and really where are we headed in the next 5 years? And the idea is that sort of how might we, in divergent and convergent thinking, to try to arrive at some statements that are going to help anchor us towards something. The next thing is to build a goal tree. And really all this is going, okay, well, now we have our vision and some idea of that. Can we try to articulate what the goal is, or at least some version of that, and identify what are the critical success factors required for that goal to be true? Like, what would need to happen for that goal to be achieved? And then behind that, what are the necessary conditions to make those critical success factors a reality? And there's often like a lot of intertwining and lines and these kinds of things, relationships. The third thing that we use as preparation really is building what we call a current reality tree. This kind of goes the other way around. It says, okay, what are all the problems or undesirable effects that we see across the system? So for example, maybe pull requests are taking too long to answer, or we've got an inconsistent approach to something, or a language hasn't been updated for a while, hasn't got to the latest version of our features for a while that we want to get to. What are the root causes of this? And so the idea of this is you build the undesirable effects, you identify the intermediate effects, but the real objective is to identify those root causes. And hopefully, despite, it doesn't matter how many real problems you've got, hopefully you identify a few common root causes that if you address those, you're gonna make some systemic changes to address the others. And all this feeds into the hardest part, which is actually formulating a strategy to move forwards. So this really involves, excuse me, I didn't go forward there. This really involves formulating a diagnosis. So we've used a particular framework or a strategy framework for this that summarizes where we are. So what is the biggest problem that we need to solve and focus our efforts on? And once we have that diagnosis and we've really articulated that in a way that makes sense to us and it builds that shared understanding we talked about, we can create a series of guiding policies, which basically say not what to do, really kind of like the boundaries of where to go to. It doesn't say how to do things. It just says, here's how we're going to approach it at an abstract level and guide our efforts without specifying how. And that those things will develop over time. And with that, also coherent actions. What are the things we're going to do right now? They're going to focus us on the biggest levers. They're going to have the greatest impact. So I won't drag you through all the detail, but let's just take a look at a bit of the output, because that's going to inform really where we are going as a community. Excuse me. Okay, so this is our summary of the diagnosis. Maybe a quick read through that, but basically it says, Pact's value proposition is weakened by the larger state we've got. We have a really large set of repositories, or a huge amount of repositories we have to handle. And that stretches the maintainer group, right? We can't all do everything all the time. And that we also have an inability for all the key languages to keep up to date with the latest features and an effective process to actually address that. We go on to say, okay, well, that's the general challenge. To move forward, we need to create a stability in the system, invest in scalable processes, and focus on creating a compelling maintainer experience. So you might be a little surprised at the bluntness of that statement. Of course, this is kind of internal, right? This doesn't mean we think Pact is bad or you shouldn't use it or whatever. We think Pact is awesome, but we need to be honest with ourselves if we're going to make big leaps forward. And so the stability aspect really reflects the feature gap in certain languages we've got. or we've had at least, and as well as improving some of the rough edges of these new capabilities we built, right? So that developer experience angle. Scalable processes really reflects that challenge we have in maintaining a large number of open source repositories with, essentially a finite amount of people. That's a problem for pretty much every community. And the third one is maintainer experience, which is reflecting the need to make it easier for maintainers, both new and existing, to continue to develop or maintain and evolve their client languages and focus on what's most important for them, as opposed to getting stuck in busy work and whatnot. So with those statements out in the open, we can then come back and revisit the vision, but we've now applied it with some more focus that's going to help us get there in the meantime. Hopefully this is really interesting, by the way. Like, I think sometimes, how the sausage is made is maybe a little bit, interesting, maybe a bit confronting, but I think it just goes to show behind the scenes the kind of work that goes on to get to a point of making decisions. In any case, we have a 5-year vision and a 1-year goal. The 5-year vision really is to be the de facto open source API contract testing tool with support for the wider set of use cases, so technologies, frameworks, and so on, enabling organizations to release with confidence. That's the goal. In the 1-year horizon, we've set 6 kind of focal points that, with a real focus on stabilizing the current features and capabilities into all the key languages, improving the developer experience, and improving the maintainer experience. If I summarize those even further. So we have our strategic direction, we have the focal areas, we've started to remove some of the noise around the edges. Let's discuss the interesting stuff, which is, what are we actually building that we're going to give you as a community to address those things we talked about? And there are four key initiatives in this space. The first one is the implementation of the Pact specification version 4. So Ron is usually the champion, or has been the champion of this over the years, has created an RFC for this 2 or 3 years ago, actually, that started to enumerate all the kinds of features and requirements for the latest version of the specification. We'll come into that in just a minute, but the specification is what governs essentially the features and capabilities of the framework. The second one is migrating languages to a shared core, the Pact FFI. This is what Ron actually talked about earlier and his greatest or most proud achievement. Again, we'll come back to this in a minute. Supporting the plugin framework in our key languages and improving the maintainer experience. So let's dive into each of those. So the specification, as we talked about, this is really the thing that governs all the capabilities and features that Pact has. And so the first step in getting this into all the languages is first getting it into the specification, because that's what's going to make its way into all the languages, the core and these other things. The biggest change in version 4, there's a bunch, but the biggest changes, the ones that you'll probably notice, the first one is that there's you can enable multiple interaction types in a single contract. So strangely enough, up until this point, you couldn't have message-based interactions side by side with HTTP-based interactions in the same contract. You actually have to name your applications differently, which is obviously a bit of a problem for some people. The second thing is it added a new type of interaction. In fact, the interactions were actually labeled explicitly in the new contract version, in the new spec version, but there's a new support for synchronous messages. So before you could do asynchronous messages, so fire and forget, you can now do request response style messages in the latest version. And the third one is allowing arbitrary interactions, as in the definitions of those, through plugins. So these are kind of user-defined, or could be user-defined interactions that basically get put and serialized into the contract file that the plugin framework knows how to handle, which we will get into a little bit later. So that's the specification. The next thing is, as we talked about earlier, is relating to the challenges of how we maintain and push changes and features through the Pact framework. But this is where the Pact Core comes in, or what we sort of colloquially refer to as the FFI, which just stands for Foreign Function Interface, because that's how you interface with it. You talk to it over essentially a C-based interface. The goals of this are to improve time to market for new features, focus our efforts on the client language development and developer experience, improve the execution speed for reasons we'll get to in a second, and improve the compatibility across operating systems and environments. You can see on the right-hand side, actually, our progress towards moving things to the core. It's actually moving quite well. But let me give you a little bit of background on this, and just to give you an idea of kind of what problem it's actually aiming to solve in a bit more detail. So one of the biggest challenges with Pact, or the biggest strengths of Pact, is also one of its biggest challenges, which is supporting multiple languages and sharing the contract reliably across different versions. So one of the reasons why people love Pact is that they can write their contract test in the language that they're building software for. So if they're working in Node.js, they can write contract test in Node.js or TypeScript. If they're working in Java, they can write in Java. If they're writing PHP, they can write in PHP, and so on. And the beauty of this is the contract gets serialized into a format that's interchangeable, and we can communicate across those language boundaries. The downside is we now need to support all the features, the rich features of Pact across all these languages. So if every single language needed to build all this logic to do this from scratch, there's a huge amount of permutations to support all the different specification versions on both the consumer and the provider side, multiplied by the languages. So you can just imagine the amount of work to do that. Coordinating that change across the open source estate is just a challenge. And so several years ago, maybe 5 or 6 now, we embarked on a strategy to build what we call a shared core, and that was written in Rust. And Rust was chosen for a bunch of reasons. For one, it can build a native C interface. It's got really good type safety capabilities when you write the code. We saw it growing as a language, so we put a bit of a bet on that as well. It can model complex types. It's really performant. There's a whole bunch of really good reasons. And the idea would be all the complex logic and all the core behavior that can write to the Pact file, read the Pact file, understand all the features, and also handle things like plugins, which we'll get to, will be put into the core. And that gives more focus for the contributors and the maintainers to focus on the developer experience and the APIs for the users, rather than having to reinvent that wheel each time. And largely that's worked pretty well. We actually previously did this kind of using Ruby before. We've actually bundled, some of the languages actually have a bundled runtime Ruby embedded in the language. And so PHP, Python, JavaScript, probably others I can't think of right now, Go, did this. And there's a bunch of challenges with doing that. For one, a lot of security frameworks saw that and thought it was like some kind of virus running inside your ecosystem because you're shelling out to binaries. And you had this kind of Ruby runtime hiding there. And also Ruby wasn't as compatible across operating systems. I think Yusuf's actually done great work in improving that situation. But there's actually a bunch of reasons why we needed to move to Rust, including not the least, that Rust actually has all the new capabilities and Ruby's a bit behind on that. So the FFI work is mostly complete, or I would say complete. And the job now is getting our languages, or the client languages, using that shared core and getting on to the latest features. Despite having the shared core, where the key logic existed, there still wasn't a way to extend Pact in ways that we couldn't fully predict in advance. That is, let's say if we wanted to build some new capability that didn't exist in the core yet, we could go and add it to the core, but if it was a entirely new thing, for example, supporting protobufs, well, that would require a whole bunch of new FFI methods, probably, and a whole bunch of new APIs or DSLs to add to each consumer language, and that would all need to be wired in. And then the next day, someone might go, actually, I really want to support CSV too, please. And then that would require that same change that bubbles through the whole system. And this is where plugins come in. It's really about, one, talking back to that multi-protocol story we referred to earlier, allowing us to expand to the widest range of use cases, technologies, frameworks, the largest breadth and depth of technology, improve the time to market for new features. So we don't have to go, cool, we've got this great idea for a new feature. Let's get every maintainer and language to build that into their APIs from scratch each time. And of course, grow our community, because despite the core being this really great thing, it is quite a big piece of software now. And so it might be daunting for some people to come into that. But where our hope is, and what we've seen, is that it shouldn't be as daunting to go and build a plugin, because that's a very contained thing off the side. It doesn't require you to contribute to an existing project. You can just build it in your own language off the side. Plugins allow you to extend Pact in a few different ways. Primarily, you can extend it by creating a new transport. So gRPC, for example, or WebSockets, ones that have been created. Or you can build new content types. So protobufs, Avro, CSV. At some point, we'll support matching rules. And maybe we'll support other things as well, like middleware to be able to, inject and modify auth headers, for example, across plugins. We don't know where that's going to go. That's part of the fun of designing software. We're going to have to sort of figure this out and work out the use cases as we evolve going forward. But the idea is you can build a plugin language. Actually, I'll get to this in a second. Excuse me. So the third part, and this is where it intersects back with the Pact specifications, is now what you can do is by using plugins and combining it with interaction types, you can actually start to model a lot more advanced use cases than you could prior to. So if you think about it, we've got this concept of a synchronous HTTP, right? So that's the same as you're used to. You can model RESTful services, you can model SOAP with that, you can model JSON RPC, GraphQL, they all run over HTTP. The use case on top of that is just the payload. We can obviously model fire and forget through async messages. So Kafka, fire forget, server push, these kinds of things. And then the latest you can now support because of Pact v4 and the plugins, of course, is synchronous messages. So you can do things like gRPC and protobufs or WebSockets or MQTT, data pipelines, Lambda, so on and so on. And the real objective here, or the real outcome, is that you can combine these different interaction types with these different plugin capabilities. And that gives you rich support for whatever frameworks or protocols that exist or emerge. And our hope would be that if you're working on a contract testing solution in your organization and you come across a use case that isn't currently covered by Pact, you could extend Pact by creating that plugin, whether you open source it or keep it within your organization for whatever reason. It would enable you to find parts of your system that you previously couldn't do contract testing for, because with these different, these primitives and these basic types, you can bring them all together or combine them to solve a problem that you couldn't solve before. And so hopefully that's how we can really start to address a much wider set of use cases than were previously able to be done before with Pact. The final piece of the puzzle, or at least part of our strategy, is making it easier for contributors and new maintainers to make changes to Pact or to the languages, or to create a whole new one from scratch. So there's a bunch of things here. These aren't all of them, but these are some of the key ones. Of course, the specification is at the core of this, right? Is it's going to govern the contract, if you will, between the features and how the contract file will actually be serialized. And that essentially governs what can be communicated between languages. We have built JSON schemas for those, which is, I think, is going to really help with tool builders to take what is a text-based specification into a computer-based explicit contract. We've talked about this a few times today. The third thing, which is kind of where that graphic on the side is the compatibility suite. So one of the pieces of feedback we've got from maintainers and from the community is, how do I know I've got a language with how do I know what my language supports? What features does it support? Pact is a very rich tool now. And in some cases, there was requirements or features in there that maybe weren't necessarily visible across the ecosystem. By building a compatibility suite written in Gherkin, so BDD, this actually describes all the features of Pact across all the different specifications and how they create not just the explicit schema that generates a contract, but the behavior associated with that. And our hope, again, is that as we build and modify our software, we'll be able to apply the compatibility suite as a bit of a regression suite across all the languages to bring them into line and make sure they've got all the features. Of course, it'll take us time to get there. The next thing on top of that is once we've and we'll talk about this in a minute with Josh, the idea is to build a much more comprehensive maintainer guide to help people understand how to build the software and interface with the FFI. It's obviously documented, but having a really well-written maintainer guide, we think will help, and we believe will help the existing and new maintainers get involved. We have a bunch of work to do around issue triaging, process automation, and just kind of updating and getting a general process across the ecosystem that enables us to drive effective change across the ecosystem that hopefully reduces the amount of busy work that our contributors and maintainers have to do, but also address and improve the way we communicate with our audience. We'll be a lot clearer with what features we're working on, where they're at, and really what a process looks like from start to finish to get a change into the system. So there's a bunch of works on that. And finally, we have these weekly maintainer meets. I think they're usually on a Wednesday, but we'll probably mix those up. And the idea is that, the maintainers can get together, whoever wants to jump in, and we'll work through an agenda. And it's open to anybody in the community to also jump in if they have questions or comments or feedback for us. Obviously, we would encourage that. So very quickly, how can we get involved? You can join those maintainer weeks. Let me say that again. Join our maintainer meets. That's a mouthful. Each week. It's in our maintainers channel in the Pact Slack. Come in there, discuss ideas, get involved. We would love for you to create a plugin or a language. We think the primitives and the work we've been doing for this now is in a much better place than it was about a year ago, given all this work we've done. If you're the kind of person who's like, I really want to build Pact Elixir or Dart or whatever it is, we have a lot more resources for you now, and we'd obviously do our best to help you as well. And lastly, join Slack. If you're not in Slack, join our Slack. It's where we all hang out, help by answering questions, be part of the community, participate in all the fun that is Slack. And of course, if there's anything we can do for you, ask a question. We would love to help. So hopefully that gives you a bit of a sense of where we've come, why Pact is still relevant, and more importantly, where it's actually headed in the next few years. And so we talked about it earlier that maybe Pact will be disrupted and won't exist in 10 years. And maybe that's true, maybe it's not. But in the meantime, we're going to do our best to make sure that it maintains relevance, and that when you ask ChatGPT how to do contract testing and apply it, it's probably going to find answers from Pact and from our Pact examples and from our Pact code base, rather than for now come up with its own first principles. And with that, I'm going to hand over to Yusuf, who I think is going to give us a few more updates.
Thank you very much, man. Resume our share. Fantastic. So I've got a selection of updates from the Pact community, and I'll be introducing some special guests. So first off, there's too much activity that happens in the Pact community to be able to contain in a single update, even if I had the entirety of today to tell you about what's going on. So every single month, we post a roundup of the month's activities. You can go to it on docs.pact.io/blog. It's published monthly, every third week. It's got all the latest changes across the open source. We focus, or we try to focus with a community corner section every month. So if you're doing something in the Pact community and you'd like to share it with others, feel free to get in touch with us in the Pact Slack, or drop me an email and we can get you featured. Also, if you are doing events or talks or videos or any kind of material, just feel free to let us know and you can get featured on our blog. And I've got a special guest to present to you, or to bring to the Pact fold. So it's Joshua Ellis. So Joshua Ellis has joined us under our parent company now, SmartBear. And he has been given the good fortune to be able to work on the open source project as part of his full-time job. So without further ado, I will introduce to you Josh Ellis.
Thanks, Yusuf. That's great to be here. And yeah, so like Yusuf said, I joined SmartBear a little over a month ago now. So I'm probably the newest member in the whole Pact and Pact Flow ecosystem. So and I come from a background in academia, so I'm really keen to contribute the kind of the open aspect of the open source tools, and my main focus will be on the Pact Python implementation initially. So what Matt was talking about before with the Pact Python implementation still using the Ruby runtime, and now wanting to move that to the Rust core and using the FFI, so that all of the new features that are developed in the Rust core can automatically kind of very easily go into the Pact Python implementation. So I've done a little bit of groundwork initially on getting a lot of the Rust library bundled in, getting the FFI working. There's some initial work you can see on GitHub also, focusing on the maintainer experience, because that's going to be my next thing, my next big task after this initial work with the Pact Python. Is going to be the maintainer experience, to make sure that the contributors can feel welcome, can see and identify where where to work on tasks and what jobs to pick up if there's something like if they've got an afternoon free, so that can be done easily. You can see that there's already a bit of a change in the way issues can be raised within PactPython and features can be raised to kind of systematize that a little bit more. That's some initial groundwork there. And you're welcome to try that out, even if it's just to stay and test it out and just comment on it. Also looking at the contributing docs as well. You can have a look at that all on the PactPython repo within the Pact Foundation. And then longer term for PactPython, the version 3, as I mentioned, supported by Rust. It will be thoroughly typed as well. So all of the typing, static typing goodness you get and auto completion you get with that. And I'm also looking at updating the docs on that and making sure that you get really updated API docs generated automatically from the code, and integrating that well with the docs.pact.io website. So that's my main focus initially. That's the first kind of few months for me joining this team. And yeah, I'm really looking forward to seeing how Pact keeps on improving. So yeah.
Awesome, thanks for that, Josh. So just how can if people are into Python at the moment and they're itching to try it out, what can they do? Just drop into the pull request and start reviewing stuff?
Yep, yeah, there's a few PRs there, which there's a few issues outstanding at the moment. There's some which are a little bit easier to address than others. I've also done a project board on GitHub so that people can see what's being picked up by, like, for example, myself. So like I've got this, I'm going to start this in the next couple of days. Maybe let's not double up on the work, but if there's something else in the backlog that piques your interest and you're keen to get started on that, definitely have a look on that. So yeah, again, on the PactPython repo within the Pact Foundation GitHub organization, and you can see the project board, you can see the issues there, so ready to go. Yeah, and even if someone wants some help as well, like if they want to put their hand up and say, yeah, I'd like to try and do this, reach out on Slack or reach out to me directly, and just ask, and then I can guide you through that. So yeah.
Fantastic. Thank you so much, Josh. We'd also like to welcome Sergey, I'm going to say this absolutely wrong, Lakalev, Sergey Lakalev, who joined. He also has a rich history in Python open source, and we'd like to give a special shout out to Mike Jeeves, who's been great compadre and contributor for the Python team. So thank you so much for that, Josh. I know you're joining in from Australia, so you can enjoy a nice nightcap, get to bed, and hopefully get on with those PRs so everyone can get that Pact v4 functionality. So yeah, thank you so much and welcome to the team.
Thank you so much as well. Thank you.
Brilliant. So what's next? So as Matt said, a lot of the libraries are marching towards the Rust core and bringing in the v3 and v4 functionality, so you can test your HTTP systems, your message systems, and leverage the Pact plugin functionality. So I'd like to introduce Tien Vo, who's been working on the Pact PHP project. So it's a little bit of a hello, and I'm presenting on Tien's behalf. So Tien's been working on the Pact PHP project for around 2 years now, and he first found out about Pact from his ex-colleague. And when he was speaking to his ex-colleague, he was discussing some of the problems he was encountering when he was working on these microservices. So those 2 pain points were testing the calls between these microservices and then the coordination of the deployment of these. So Tien took a journey, and it started with him trying to test Pact PHP with Symfony, so a PHP framework. But he was struggling due to a bug that he found, which under a bit of investigation into the kind of GitHub repos, he identified it as being an issue with the Pact core. So he took that opportunity to But he also, whilst he was looking at the GitHub repos, he noted that Ron had been working on the Pact Core rewrite to Rust. And Tien really relished this opportunity to first learn more about Pact, really by looking at how the reference implementation hangs together, but also to learn Rust. It's a new up-and-coming programming language, and he's interested in PHP at the moment, but it's a really great experience to marry two kind of learning experiences together. But he did find some challenges with trying to integrate with the Rust core. So first there were some peculiarities with PHP's FFI interface itself. And he actually found that the Rust code is not so easy to read, and he was struggling to debug it at first. And then more generally, in order to find more about the Pact project, he built in his own home lab, which is pretty cool, and you can talk to him to find out more about it. He built a more production-like environment to kind of sandbox and test out his Pact PHP changes. So what has he actually been up to? So Pact PHP has been lagging because it's been using the Pact Ruby core. So in order to provide these V3 and V4 features, Tien has been working on and now released an alpha version of V10 of Pact PHP, which includes the Rust core and the newer functionality. We're expecting the third alpha to be published soon. We implore you to come along and help review some of those PRs. And we'd like to move that development to kind of a beta state so that both Tien, his employers, and hopefully you can try it out in your own project. So what do we need from you in order to help move this on? So we'd love more reviewing. There's some PRs that are open at the moment. We'd love more testing. If you're using Pact PHP today in your project, we'd love you to try out this new version. And we'd love more PRs from other contributors. We know that things might not be right first time, but Tien's not expecting to do this alone. And because it's an open source community, anyone can come along and help contribute. So we'd welcome and invite you to that. So we'd love to thank Tien for all his efforts. We're really pleased to see that package being published as an alpha on packages, so Pact PHP users can use it. And like I say, it's really nice for me to see that Pact PHP and Pact Python, because they are still quite popular languages, are going to benefit from these Pact features. And as Matt says, if you're looking to build a library in the future, we're going to take some of the learnings from Tien's experiences and Josh's to improve our maintainer experience. We've also got some Pact course updates. So if you check out the Docs website, you can check the Pact University. There's a few different courses on there. There's an introduction to Pact. There's a CI/CD workshop. You can learn how to create your very own Pact plugin. And you'll see some more workshops appear there as we go through the month of Pactober. One additional thing to say, they're all, because we're open source at heart, they're all MIT licensed. Please use them, share them, tweak them for your organization. They will definitely help the organizational adoption. And if you want to create a new course or you don't see a particular technology covered, please feel free to create a sample repo and then we can mob around it and implement Pact into it. And furthermore than that, feel free to share your knowledge. We can provide a platform for you. And we'd like to say a special thank you to Rafaela so bad with names, Azevedo. And she is an amazing teacher, educator, and entrepreneur. She worked on the test automation course, which you can go and check out today. But I can't do Rafaela enough justice in my own words. So I'm going to leave us with a video from Rafaela just telling us what she's been up to and how you guys can help out.
Hey y'all, I'm Rafaela and I'm the creator of Contract Tests with Pact course in Test Automation University. It is free and you can learn about the basics of contract testing, how to set up Pact framework in the project, and also continuous integration, continuous deployment. Today I'm gonna give you some updates about the course. Yeah, just a bit about me. I have 16 years experience in QA, mostly test automation, test strategy, architecture, and leadership. I have done the full cycle in the development, so I have worked not only for big corporations, but also with small startups where I had to build the QAR from scratch. And I have done, played different roles and wear different hats where I had to be not only a software developer in that, but also a DevOps and a developer at the same time. So I created this blog in 2011, hbdurafala.com. I'm gonna share more in the end, but it is not only about QA, and it's about sharing my experience and my knowledge with the community. So you can find posts about career development, interviews with other QAs, and the challenge they overcame when moving to another country, workarounds in plugins and frameworks, bugs that are found in plugins and frameworks when testing and using in my projects, and how I learned some of the other things. And I'm actually from Brazil, a seaside town called Santos. I know that my hometown is quite famous because many footballers, they came from there. So Robinho, Pelé, and Neymar. I hate football, and I'm a fake Brazilian, but yeah, that's it. And I moved to London 10 years ago. And now I'm not going back to Brazil probably ever again. Joking. I go just for holidays and see my family and friends. But yeah, now I'm in this mission to bring more developers to Web3, and is through micro-learning and having real experience with commercial projects where they can collaborate with each other. And we did that through Chain Academy. In the course published, you learn what contract tests are, when to apply them, and how to set up your test framework with Pact. It covers the advantages of contract tests, how to set up a framework using Pact.js, how to implement the test on your provider and consumer, different types of matches you can perform with Pact, best practice for implementing a contract test framework, handling authentication and authorization, analyzing test results and common issues, and lastly, continuous integration and deployment. Pact supports a variety of languages, but the course is written on JavaScript. Don't worry, because the concepts are really similar regardless of the tech stack being used. Contract tests is a crucial aspect of software development that ensures the quality and the reliability of the software. It involves verifying the functionality of the software and the product based on predefined agreements, which describes the expected behavior of the system and provide a clear understanding of what the system should do in different scenarios. One of the biggest misconceptions is to think that contract tests by itself is enough, but without proper communication, contract tests can derail completely. It is actually a test for your communication between the teams. To overcome these challenges, it is important to use clear and well-defined contract specifications. Test early and test often. Use automated testing tools and involve all stakeholders in the testing process. Pact framework got me straight away when I was in the Greenfield project where I did a benchmark with the available tools. And then I noticed how easy it is to set up the framework, and also the maintenance is reduced to a ridiculous minimum level of running the tests again. It is one of the best strategies for when you have a complex microservices structure. And you need to test the integration with the minimum effort possible. So it always use the real thing. You don't need to worry about maintenance of the mock and creating everything from scratch. It is life-changing indeed. So yeah, the course was published in 2020, and since then, Pact had many updates, as you can imagine. The course is using 9.7.0 version, and in the present moment, we are on the 12.1.0 already. You can only imagine how out of the date it is. And the sad news is that Automation University is not going to be able to update the course so soon. So one of the things that I have in mind is, I'm a big supporter of the open source and the community. So it would be really great if we can all update the course, from the community. And one thing that I'm going to do is giving the swags to the 5 course contributors that send the PR and update the project to match with the latest version of Pact. Just need to send like a message to me, a DM on Twitter with your PR created, but I can also check on the GitHub, whatever is first, I'm gonna have a look. So yeah, let's keep in touch. And if you are curious to know more how you can learn about Web3 and blockchain with micro-learning and in full stack real commercial projects, just subscribe to our newsletter, the Chain Academy, and join our Discord server. But if you are just curious about Web3 tests in general, there is a community on Discord waiting for you. All the links are on the link tree, basically. You can go and just check it out. And yeah, that's it. Thank you, everybody. Bye.
Amazing. Thank you so much, Rafaela. If you didn't miss that, if you want to check out the links in YouTube, Joe will be providing them to Rafaela's course on GitHub. If you're able to update it to the latest Pact versions and use some of the latest Pact techniques, we've got swag for the first 5 PRs that are raised there. If you would like to participate, my apologies, let's pass that slide. So if you'd like to join our community, some of the benefits of participating, why should you get involved in participating with our community? So you can contribute to the future state of the leading contract testing framework. It's really nice to be able to be in a guiding position and being able to support your needs. So, it's definitely worth, if you want to participate, get along to those weekly contributor meetings. It's great for being able to build your own profile. So as some of our speakers have said today, although contract testing is a useful technique to apply to your kind of software delivery lifecycle, it's a great thing to talk about, especially with lots of people wanting to know about it. So you can build your own profile around it. There's lots of great stuff. So Lewis's podcast, etc., and you can connect with any of the team who'll be able to give you advice. You could be here next year or at one of our other events that we do within the year, speaking or showing some of your skills. You can technically upskill. So if you're not necessarily proficient in one particular language, you can learn by example. So if you're into JavaScript or Golang, for example, you can maybe look at one of the other Pact implementations. And more importantly, you can get some swag. So we've now been able to secure some goodies to be able to provide with our community. And with that, I'm going to hand it back to our lovely Elliott, who will be able to take us to our end of the show.
Cool. Thank you. Lovely to see all the different faces, particularly for me, Josh, because I've been remiss in Pact Python, so it's been really great. I know we've got to catch up separately. We will do a quick Slack messages to help you out, but welcome and loving your work. And great just to see from Matt where we're going, all the progress that we're making. The Rust FI stuff has been a lot of work, and but absolutely, definitely the right way to go. Okay, so moving on. Hopefully, we have JB Rainsberger on? Just looking at our participants yet? Are we still waiting for Air Canada to get them here?
We are still waiting for a JB.
Okay, So hopefully he'll be on in a second. So I'll start the drum roll for him, and hopefully we can get hold of him in the meantime. Otherwise, this will be me speaking for quite a while. So our last speaker is traveling from Canada, is coming in from Canada. So hence why we're trying to connect from him. He's actually on Prince Edward Island, which I had to go look up, which is a really beautiful spot by the looks of it. There he is. He's just popped on. And I think probably one of our more remote spots, though it looks like it probably gets a little bit cold there in winter. I became aware, so my background is as an engineer. I was, going to go back a few years now. So I was working in the States in, I think, the late 90s. And I got introduced to TDD back then and unit testing. And I was a pretty junior engineer. And I just thought that's how teams worked. And actually, I didn't realize that was quite a novel thing back then. So now it may not be so novel, but certainly back in 1999, it really, really was. But I was very junior. I just applied it. It just felt good. It just kind of worked. I just wrote better software that worked most of the time, and that was all great. But I didn't really understand the context of why this was better than other testing. And I had sort of journey that went through where I left that job and worked in other places, and they didn't really do TDD or unit testing or anything like that. And the technologies weren't quite as sophisticated as they are. Things like mocking and stuff was very difficult. We had to sort of home spin all our own things. And so later on, as it started becoming more adopted, I went through this sort of journey as I became more senior because I became a tech lead and starting to set up sort of test strategies for my teams. And one of the things that really personally helped me understand, real power of like unit testing and think about what tests you need where was actually coming across JB Rainsberger's integrated test or a scam talk. And it basically, I think for anyone who hasn't seen it, and you can see, we're going to see a slightly modified, I think a more empathetic version, if I can say that for him, was really just trying to explain like the basic maths about why you can't just do these large integrated tests at scale. At a certain point, the maths don't stack up. And then how you should apply these techniques to solve these sort of problems. So I'm going to stop whittling on again, and I'm going to hand over to JB. Welcome all the way from lovely Canada, I hope. And yeah, I'll let you take the floor.
All right. Well, first things first. Test 1, 2. Am I on?
You are, and
Marvelous.
We can hear you loud and clear.
Excellent. All right. In that case, let us begin. And let me remember to do the extra thing I need to do. Oh, that's disappointing. Share sound is disabled for me. Is there anything that we can do about that, or are we out of luck?
I can hear you. Sorry, what's wrong?
I can't share sound. I do have a clip. And this somehow, share sound is not enabled for me. I don't know if that means that I just need to be promoted in some way.
JB, I was able just to share sound without enabling anything, so it may just be enabled.
Let's see if it works then. All right, we'll do it live. Awesome. Legacy Systems, everyone. Welcome. Okay, so thanks very much for inviting me to be part of the 10th birthday celebration. It's really nice to, one of the things that marks the career of a consultant, or indeed any kind of freelancer, is not knowing what happens after you leave the room. Often you show up for a week, 2 weeks, a month, some relatively short period of time, sometimes as little as a day. And then you have no idea what happens after you leave the room. And that can be unsettling for somebody who actually wants to feel that fulfillment of having some kind of an impact, of knowing that you've done something to help people, and that you're not merely shouting opinions into the void, which I can tell you that over the last 20 years, it's felt a lot like that. And so when, when you reached out to invite me to this, to be part of this, that was a really nice way to let me know that something I said worked in some way for somebody and help them in a meaningful way. And so I'm really happy to be here. But let's get on to the show. So you'll notice a slight difference in the title, Beware the Integrated Test Scam. So I'm here to do three things today, to look back, to apologize, and to offer what I hope is some hope for the future. So I'm curious, does anybody else out here remember extreme programming? Maybe not everyone has quite the same amount of gray that I have, but if you're a programmer of a certain age, then you might remember when extreme programming started to become popular in the late 1990s and early 2000s. And there were a couple of things that I really remember from that time. One of them was all the jokes about the X Games, about what extreme meant. Does that mean that you're going to be, programming on BMX bikes? Or you're going to be rappelling off the side of a mountain? No, that's not what we meant at all. But the other thing was, especially if you managed to read the first edition of the first extreme programming book, Extreme Programming Explained by Kent Beck, you might recall, and I don't think Kent will mind too much my saying this, the ramblings of a frustrated programmer, or maybe a swift call to action from a frustrated programmer, someone who wanted to lead a programmer revolution. I remember at one point Kent calling computer programmers the world's richest oppressed group. And what came out of that was a whole bunch of, as I say, exuberance and bold statements. That was the extreme in extreme programming. It had nothing to do with X Games, and it had everything to do with, one of the old sayings was, if this is good, why don't we do it all the time? And so in the extreme programming community, we made a bunch of bold statements. You should do it this way. It needs to be like this. If you do this, it will be better. Turn feedback up to 11, turn courage up to 11, turn communication up to 11, and see what happens. And I think, as far as I understood it, the original idea was, let's scream, let's get as many early adopters as possible, and then see what happens and how they carry the ideas to the rest of the community. A bunch of us had been reading the Crossing the Chasm had come out around the same time. And so the idea of how do we cross that chasm from the early adopters to the general majority was a big question. And a lot of people liked what we had to say. I mean, I certainly liked it. I got sucked in. I'm here today in part because I read those books. But a whole bunch of people were suspicious of us, and not just the ones making jokes about extreme, but the ones who kept telling us that in the real world, it didn't work that way. And so, we had this vision for what we thought the future could be, and we screamed about it as loudly as we could. And then we had to pivot to addressing the masses. When it came time to cross that chasm, frankly, I think our marketing message wasn't up to the task. I think we didn't have enough people who had expertise in the differences between marketing to the early adopters and marketing to the general majority and the latecomers. And so depending on when you start counting, we've been trying to clean this mess up for anywhere between 15 and 25 years. And I think by and large, most of us had given up. And now there's a small group of still relatively rabid fans of extreme programming, and some people like me who really cite extreme programming as being a huge part of where we came from, but who don't quite have the same kind of extreme fervor that we used to have. I think we hold many of the same convictions, but we've gone not only away from the firebrand marketing, we've even dialed back on the strong opinions weakly held, and it's more like, hey, this is a really good place to start. This is a really good tool set to have in your toolbox, but it's probably wise to be able to do other things as well. And I mention all that not because extreme programming is so relevant to what I want to talk about today, but more because I see a really big parallel between the path that we've been on with collaboration and contract tests and what the extreme programming community has gone through, where we're older, we're wiser, we've seen more things, we've seen where our ideas work and don't work. We've seen the struggles that people have and don't have in trying to adopt what we're trying to sell. And we've learned some things along the way, and maybe our message is a bit softer than it used to be. So let's see if sound works.
No sound. But we are.
No sound?
No, unfortunately not. I have promoted.
Oh, that's a pity. It's only 20 seconds, so it'll be over soon. You can imagine what it sounded like. This is the opening to integrated tests are a scam. The huge, the world is going to end. Integrated tests are going to kill you. It's going to destroy your life. And I played that once. And in fact, you know what? It's even better that you didn't get to hear it, because I never want to hear that again. I'm embarrassed by that now. I mean, I understood what I was trying to do at the time, and I don't necessarily blame myself for it. I did the best I could at the time, but that tone's all wrong. The ideas in that talk I still stand behind them, but the tone is all wrong. And so now when I talk about integrated tests and when I talk about the difficulties, the scam is still there. I really want to emphasize that the ideas are the same, but the delivery has changed. Not just kinder, gentler, because I want to be kinder and gentler, but because it's not quite as, I don't think I need to shout from the rooftops anymore like I used to. I did that for 20 years. I'm happy to have done that. I did it for the first time in 2003 at the SD West conference. It was the first time anyone was willing to listen to these ideas. I think I got it all out of my system now. The scam hasn't changed, but what's changed is how I present these ideas to clients, to colleagues, to peers, so that they recognize that there is a hole. Please don't fall in the hole. I'm not necessarily going to scream that the house is on fire, but I will point the hole out. If you fall in, I'll help you get out, and then you'll realize, oh, I don't want to fall in that hole again. So let's say, beware the integrated test scam. Now, I'm not sure I've actually told the story before, where scam came from. My wife, Sarah, the queen of docs, who is now a celebrity in the Astro project community. She had her conference while I was gone at this bowling tournament. She spoke at VeetConf and was a big part of it. So congratulations to her. She likes to call everything a scam. That's her joke. Insurance is a scam. Anything that doesn't work as advertised is a scam. And I found that funny. So because integrated tests don't necessarily work as advertised, it became a scam. From that day, at the time, integration tests were a scam. That was the joke. And I thought, even though it's just an inside joke between my wife and me, I think others will kind of get it. But of course, Jerry Weinberg's The Law of Raspberry Jam kicks in, right? The wider you spread it, the thinner it gets. And I think a lot of people took the scam part a little too seriously. So even before I changed integration test to integrated test to try to clarify that part, the scam part, I think, is the part of my legacy that I'm not particularly happy with. But if you let it be a joke, if you let it be hyperbole for the sake of humor, then I think it stands. I mean, integrated tests will destroy your code base if you let them. They will slow you down. They will cause you to not trust your tests. And they will force you to duplicate effort. And the more you rely on integrated tests, the more expensive they become. It's like buying medicine that makes the disease worse. This is the only metaphor that I found that actually helped really explain my position. And since maybe not everyone is so familiar with the talk, the very short version of integrated test is any test that runs more parts of the system than you're trying to check. So if I'm trying to check this part over here, if all my assertions are concerned with, one value or with one set of side effects, but I'm forced to run a larger part of the system in order to check that, that's an integrated test. And the opposite, you know, you can call it a solitary test, an isolated test, a micro test if it happens to be small enough. Let's not go down that rabbit hole. But the opposite is some kind of focused test, a focused unit test, something that runs only the part of the code that you're trying to check. And of course, the goal isn't to make every test as small as possible, but rather to understand that if you allow your tests, if you rely too much on tests that run more of the system than you're trying to check, then you're going to slowly, gradually stop trusting your tests. Because 37 tests will fail even though there's a tiny problem over here. And so somebody will stop the line. There'll be a quick stand-up meeting. People will be panicking, and somebody will realize that it's a tiny typo somewhere. That's not a big deal. If 2 unit tests failed, then you'd have a very different experience. And so the integrated test scam is that if you rely too much on integrated tests, it's like buying medicine that makes the disease worse. And you can mitigate this damage with attention to detail and particular techniques. There are other ways to do it. You can even live with the damage if you want. But there's a very nice thing that happens. If you try to do the kinds of things that help mitigate this damage, working with collaboration and contract tests, programming to roles and interfaces, we'll get there in a moment. Trying to mitigate the damage actually nudges you towards designs that are in some ways better, that create more reusable pieces, more recombinable pieces, and that teach you something about design. One of the things that I hear repeatedly is you can't do good test-driven development until you understand design. And I can't have this argument anymore. Well, no, I can. If you pay me, I'll have the argument as much as you want. But I believe that you can learn those principles of design deeply, internalize them, and they're yours for life through practicing test-driven development. As you try to practice test-driven development and you notice things like the integrated test scam, and you adopt the idea that if the tests annoy me, the problem is with the production code design, then you can learn all the principles of good design and own them for life. Learn them at a pace that you will actually understand them and be able to apply them and actually use them as part of your work, instead of it just being ideas in dusty books on the shelf that you never look at anymore, that you read once and put away and never use. And for me, maybe the most important part is this last part. You can do it. There is no need to fall for the scam. You can figure this stuff out through practice. It's good to have people like me, like the people who supported me when I was growing up, to be able to ask questions, to be able to ask the biggest question, which is, I tried to follow the rules and it made me do a thing that seems wrong. What does that mean? Now, 20 years ago, it was a lot easier to just go to Google groups where everybody hung out. They were all in one place. You could ask them a bunch of questions and probably get 20 good answers in a day. It's a little harder these days, right? The social media landscape and even the website or community, the sort of online community landscape more generally has become much more fractured. Do I go to Quora? Do I go to LinkedIn? Do I go to X? Do I go to Mastodon? Other parts of the Fediverse? Lemmy? I have no idea. But if you wander around the desert, you will find your tribe. You will find the people whom you can count as trusted advisors. I'm willing to be one of them. As long as you're willing to wait forever for the answer, that service is free. And if you need a better service level agreement, we can talk about how much that costs. But the important thing is you can learn this stuff. You don't have to. It's not life-threatening. But you don't, if you find yourself in a situation where you feel stuck from these integrated tests, there is a way out. You don't have to be a wizard to do it. You can learn it as you go, and I promise you it's not as hard as you think. Now, all of that is not nearly as catchy as integrated tests are a scam. They're going to destroy your code base. They're going to drive you insane, and your life will be over. I admit, it's not as catchy, but it has the advantage of actually being true. I believe that those points that I made moments ago are a much more accurate representation of the situation. And if you caught me at a conference, or if you asked me a question in a nice, private, quiet moment, even 20 years ago, well, maybe not 20, 15 years ago, I would have said those things. But I thought I needed to shout it from the rooftops to make people listen to me. Marketing is hard. I had to feed my family. Now, the integrated test scam hasn't changed. Here it is in a nutshell. This is almost the same diagram that I drew for the first time 20 years ago. And it starts with, at the top, our tests are all passing, but we find a problem. And that, almost by definition, is an integration problem. If you do even a reasonable job of writing any kind of unit test at any scope of the system, and especially if you try to write smaller and smaller tests, it seems likely that the behavior of the individual pieces will be what you expect. But then when you try to put the pieces together, they won't quite fit. And this is the kind of thing that causes people to say, oh, we must have holes in our testing. Let's go to the testing pyramid or the testing rhombus or whatever the hell people are calling it now. But they start saying things like, we have holes in our testing and we need to fill those holes in. So you can use the Swiss cheese approach. There's a whole bunch of things out there that you can learn. But what seems to happen is that at some point, someone who thinks they're playing the role of the adult in the room, a senior programmer, an architect, a well-meaning project manager, a well-meaning product owner who is a former programmer, will say, well, you need system tests, end-to-end tests, some kind of bigger test so that you can fill in the gaps. That's one of the layers of cheese in one of the cross sections in the Swiss cheese thing. Okay, it's a choice. I want you to be aware of one of the key risks, and that is that integrated tests, by their nature, run bigger parts of the system than we're trying to check. That's the definition. And especially end-to-end tests are the biggest integrated tests you could write. Big tests have one serious flaw. If you use them as part of test-driven development, and particularly if you're in stage 2 of test-driven development where you're doing test-driven design, where you're really relying on tests to give you feedback about the quality of your design, bigger scope tests put less stress on the design. So dependency problems are not as apparent from tests. Now, you'll still have duplication in your tests, but the one thing I've learned over 20 years is that programmers can get numb to duplication in tests pretty quickly. So maybe it's not as good a feedback mechanism as I think it is. But for those who are willing to pay attention, once you get hooked, it becomes really nice, but sort of getting that first taste seems to be difficult. And so what that means is that because those tests put less stress on the design, it's possible to write worse code that passes those tests. You can write code where it's a tangled mess inside, but because the tests are checking they're running the system and checking from an outside perspective, there isn't as much pressure on the design to be nicely organized. And because we are programmers and we're productively lazy, that means we will write less bad or less good design to pass those tests. Even if we think we're doing a good job, again, we're productively lazy. We are also human and we want to conserve energy. So we are going to write code that passes the tests. And because the tests put less stress on the design, we're not going to notice the design flaws as easily. As a result, we will have more tangled code. I'm not saying the whole thing is a tangled mess, but you'll have islands of tangled messes. And some of them could get quite big. Once 2 or 3 of those little islands of tangled messes become tangled with each other, now you have legacy code. Congratulations, that's a whole other talk. But there's another effect that because the code becomes more tangled internally, it becomes even harder to write good unit tests. So now you're forced to write integrated tests in order to test more of your system. And the tests become wider in scope. They become more brittle. There's more hyperactive assertions that fail even though everything is fine, or explosions in the wrong building, or failure, one tiny thing causes 118 tests to fail and everyone panics. And so that makes the problem worse. What that means is that we write fewer tests, because writing tests is painful. It's painful to write them. It's painful to run them. They become a pain in the ass. So as a result, we write fewer of them. And when we write fewer of them, then the thing at the top, 100% green, and yet there's a defect, becomes more likely to happen. And that is the amplifying feedback loop. That's why the dude in the center of this diagram is freaking out. Because trying to use integrated tests to solve the problem of the tests are passing and there's still integration problems causes you to have more integration problems. Now, in principle, in practice, you can find an equilibrium, right? There is a balance to make between smaller tests and bigger tests. The bigger tests are not ever going away. You might need them for different purposes. You might need them to help give the customer the warm, fuzzy feeling that the system is working the way they intended, because your customers, your stakeholders, your product owners, whoever they are probably not going to trust your unit tests, no matter how good they are. Some have, some do. I've experienced it a couple of times, but most of the time, no. But you know what? They actually don't trust your automated tests at all. On average, spherical product owners in a vacuum, they don't care about your tests. They only care about what happens when they use the system, or when someone they trust uses the system, or when someone they trust tests the system by hand. And so you can go look up James Shore and the phrase customer unit tests. And what James has to say about the myth of automated acceptance tests, I kind of agree with. That for the most part, if we really want to do the extreme programming thing of getting a real customer, a real user to accept our features, seeing is believing, and they're not going to trust your automated tests no matter how many nice cells turn green. No matter how much you try to tell them that those automated tests mean that we understood them and that it works, unless those customers are recent programmers, they won't care. They'll yawn, and they'll still have to play with it themselves. So don't waste your time. The integrated tests are probably not going to help. You can gradually replace them with smaller and smaller tests that do a better job. So now, what do we do to avoid the scam? So whenever there's a risk, you look for mitigation strategies, limit the damage, and you look for avoidance strategies. Best way to block the kick is not to be there. So what are the mitigation strategies? And this is one of the key arguments that people make against the old integrated tests are a scam idea is, well, not always. Not all integrated tests. Fine, I agree. If your object clusters or module clusters, I'm going to say objects because I'm an old dude and so I think in objects. If your object clusters are small enough, 2, 3, 4 layers, then the integrated tests, the combinatoric explosion is still there. But if there's only 3 or 4 layers in your tests, like 4 factorial is not that big. It's only 24. The combinatoric explosion has not had a chance to explode yet. At 6, 7 layers, you're dead, right? Your project is over. We're already now firing the CTO and doing it again in Python and swearing that we're not going to make the same mistakes again. So if you make the clusters small enough, then the problem is probably never going to hurt you. It'll annoy you. And the nice thing about that is you'll never have the urgency that makes you think, oh, wow, we absolutely have to stop everything and replace all of this with microtests now. You'll never have that impulse. You'll just have this gnawing feeling that, maybe we should try to move towards smaller tests. How might we do that? How do we disentangle what we've built so far so that when we write a test, we can run a smaller part of the system that's more focused on the part that we're actually trying to check. So that's the risk mitigation strategy. As long as we avoid relying on end-to-end tests, it's probably not that bad. The problem is that most projects that I see these days overspend on end-to-end tests. Like they're literally, even if they're avoiding the UI skin, they're going from HTTP endpoint all the way to the end and coming back. At most, they're stubbing out the database. That's not bad, but I'm not sure those clusters are small enough. And if you try applying some of the ideas in collaboration and contract tests, one of the things that will happen is that you'll discover the hard lines that make sense between, say, the skin of the UI, the HTTP transport mechanism, the database at the back, or whatever backend you happen to have. Again, old guy, so I think database, but of course, I know the backends are all distributed these days anyway. And then what's inside is this GUI mess that could be a domain model. And if you work on that a bit and apply the collaboration and contract tests idea to that part of the system, magic can happen. Then you really could live the dream of testing your business rules with no thought to the technology integration. And so then when somebody says, we need this working on mobile, you can do it. When we need this working on a new browser, we can do it. We need to, REST was a mistake. We need to do something else instead. You can do it and just change a part that is pure technology that has nothing to do with the interior of your domain. And I think that's sort of the thing that's missing right now. If you do that, then the clusters will be so small that you can afford to have some clusters of objects inside your domain, and you can afford to have some clusters of objects that are pure technology integration. And as long as the two never mix, you're probably in great shape. So that's the mitigation strategy, is to make the clusters smaller. We don't have to do collaboration and contract tests absolutely everywhere. But if you've never done it before, or if you don't feel expert in it yet, you might need to do it everywhere to find out where it makes sense to do it and where it's mostly a waste of time, right? The only way to know where the edge of the cliff is to fall over a few times and then say, now I know where the edge of the cliff is. Don't go any farther. And then avoidance is the other strategy. Just don't do it. So that's where collaboration and contract tests come in, client-first design with test doubles, all the kinds of techniques that, I and people like me have been teaching for 20 years now, where we just decide we're not going to play this game. We're going to program to roles or interfaces or protocols, whatever you want to call them. And we're just going to do it everywhere as much as possible. And you might be overpaying for a guarantee. Again, that was one of the primary arguments against my idea was, JB, you're overpaying for a guarantee. Yes. But again, you need to overpay for a while to understand how much is worth paying. And a lot of people had just never even thought of this before. You can smack a person over the head as much as you want with object-oriented design or books like that. But until they've actually tried to use collaboration and contract tests in a real project under real pressure, they don't understand what it means to do that, what it means to program to roles, interfaces, protocols. This is maybe the first time in their career they've ever actually tried to do it and understood what it meant. And so you need to overdo it before you know how to do it enough. You need to underdo it, which is most of your career up to this point. You've been underdoing it. Then you need to overdo it for a while. That's what we did collectively in the early 2000s. And then we settled down. That's a natural part of the learning process. You need to allow yourself to do that. It's okay. It's okay to have a bunch of interfaces with one implementation. Nobody will shoot you. Some senior programmers might look at you a bit funny, but whatever. This is what it takes for me to learn. Let me do this. It's fine. So what do collaboration and contract tests lead to? As I've been saying, they lead to understanding this thing that people have been writing about since the 1950s, about programming to abstractions. All those old papers that the old people have been showing you that you didn't waste your time reading will start to suddenly make sense. I mean, the examples in like lambda calculus, maybe not, but the ideas will. Suddenly, it's like, woo, now I get what they were trying to do. Not only indirection, but also abstraction. Abstraction is one of those words that senior programmers use to make junior programmers feel stupid. But if you ask the senior programmers what abstraction means, if you put 5 senior programmers in a room and ask them what abstraction means, I will pay you 1,000 currency units, 1 million depending on the currency, if 2 of them agree. So let me tell you what I mean by abstraction. An abstraction is a thing that hides details. End of sentence. That's it. Helpful abstractions hide the details that you don't need and expose the details that you do need. Unhelpful abstractions either hide the details that you need or expose the details that you don't need. And finding a balance in abstraction, it's a balancing game. You don't stop. Sometimes from different perspectives, different abstractions of the same thing are useful. Think of a car. For most of us, and I shouldn't say us, for most of you, because I don't drive, for most of you, I've only ever driven twice, both of them illegally. Statute of limitations has expired, it's fine. The interface of a car is essentially the steering wheel, the pedals, the ignition, and that's it. That's the basics of how to use a car. And that's all you need to know. For most of us, we're not going to tinker with the car. We're not going to repair the car. We're going to pay somebody else to do that. All we need to know is how to make it move. That's abstraction. And a car provides some, learning to drive a car relies on a helpful abstraction of the car. You don't need to know more than steering wheel, mirror, ignition, pedals, how to get in and out of the car, how to lock it. I mean, really, what more is there? That's abstraction. Hiding the details that you don't need until you need them. And different abstractions are of different value to different people. So when some of my peers talk about bad abstractions, I don't believe such a thing exists. Sorry, folks. There are abstractions that are helpful to some people in some moments, and there are abstractions that are less helpful to those people in those moments. And I think of it that way. Do you hide the details that I don't care about right now, and do you expose the details I need? And collaboration and contract tests is not just a testing strategy, but it's a design strategy to gradually converge towards helpful abstractions everywhere. Helpful abstractions everywhere, at every layer of the system. And you don't need to extract interface types to get abstraction. You can use public-private. You can use naming conventions and pretend that the names, that the methods that start with underscore don't really exist. However you do it. But you understand that there's part of this module's interface that clients will talk to and part that they don't. And whether you enforce that with types or do it by agreement doesn't really matter. What matters is having ways to challenge the value or the helpfulness of the abstractions. And collaboration and contract tests constantly put pressure on our abstraction decisions, on our encapsulation decisions, on our hiding decisions. And again, when the tests are annoying, maybe that means that we're hiding some details that would be useful, or we're exposing some details that are getting in the way. And so we adjust the abstraction level. So again, some of my peers have said, I would gladly exchange duplication to avoid bad abstractions. I'm sorry, I don't get it. Like, why can't you refactor your abstractions? Why can't you make something visible that wasn't before? Why can't you make something invisible that used to be visible? Improve your refactoring skill and that problem goes away. I mean, it has a cost, but the whole point of refactoring is to allow us to not feel imprisoned by our decisions. And one of the nice things about working with collaboration and contract tests is they constantly challenge our choices about abstractions, and they help us. Some would even say force, I don't like to use that word, but they really do strongly encourage us to challenge our ideas about what abstractions are helpful. And when the test doubles in our tests become too complicated, that's a sign that there's some details being exposed that should be hidden. And when we have trouble writing a test at all, then that's a sign that there are some details being hidden that need to be exposed. The nice thing, even if you extract interfaces, the really nice thing is that you can always just write test implementation directly if you need access to those details, right? The mechanic cares about the interior details of your car's engine, even though you, the driver, couldn't possibly care less. And so one of the nice things about using collaboration and contract tests is that they help us address design problems before they get out of control. They're the early warning sign that this interaction is starting to become too complicated. Maybe it's better summarized by an intermediate object. Maybe you need a proxy here. Maybe you need the specification pattern. Maybe you need an adapter. That is what these, yes, these are testing strategies, but to me, really, they are design strategies. When the tests become annoying, look at the design and see what you can do to make the test simpler. They provide that positive pressure that we're looking for. If you do this long enough, you end up here. So this is another one of these magic phrases that I stumbled into about 10 years ago, that especially at the dawn of the distributed microservices revolution, if you want to call it that, this started to speak to people. If I say program to abstractions and you just glaze over, then if I say microservices in a single process, people perk up. Ooh, he said microservices. Ooh, let's find out. And that's what happens when you try to apply collaboration and contract test to your design. What you end up with is effectively microservices in a single process. And if you have microservices in a single process, how hard do you think it will be to extract those microservices into distributed parts? Not very. And in fact, one of the when people ask me, how do I test my system with distributed microservices? I say, well, get rid of all the HTTP nonsense and arrange those microservices in a single process and try to test them using collaboration and contract tests. And if you have trouble, then you're going to have the same trouble when you make those microservices distributed. There's going to be messages going in both directions. There's going to be message spaghetti. You can see that message spaghetti in tests if you try to write collaboration and contract tests for the in-memory version part of all that. So strip away all the HTTP crap, leave behind just the part that can run in a plain process, and then try to write collaboration and contract tests. And if you can't do that very well, then you certainly are not going to enjoy your distributed microservices experience. And the opposite is true. If you do this well, then when it comes time to distribute your microservices, not going to be a problem. It just becomes tedious work. You might write a code generator to do it. In fact, that's how all these magic whiz-bang, we're going to make your code magically microservices overnight. The stuff that they were telling us about at the beginning of the service-oriented architecture craze, that's where those tools came from. So ultimately, this message, I intend it to be kinder and gentler. Less of you're doing it wrong and more of, hey, you might feel some pain here. Are you feeling pain? I can help you. Now, I admit, the second message has some marketing problems in its own, right? As soon as somebody says to you, I know how to relieve your pain, the first thing your critical thinking faculties should make you ask is, did they engineer the pain so they could sell me the cure? Fair. I don't think I did. I think the pain comes from how difficult it is to learn good design principles from books and articles and courses. Because programmers, and especially young programmers, eager young minds that are trying to learn everything, try to read their way to proficiency, to expertise. And I don't believe you can. I believe you can only practice your way to proficiency and expertise. And reading, taking courses, talking with mentors is a way to push the fast forward button from time to time. But you can't read a book on object-oriented design or functional design. I mean, Grokking Simplicity is a wonderful book, but I don't think a programmer who, if you pick a random JavaScript programmer off the street and say, read this book and then come back to me and program magic, it's not going to happen. They need an opportunity to try it and make mistakes. And there's no point in yelling at them that they're doing it wrong. All that does is make them feel bad and make them feel less eager to try. I do not want to squash their eagerness. Instead, I want to adopt sort of the relaxed grandfather stance and say, look, programming is hard. Design's hard. And the learning materials really aren't that good. So when you have questions, come here and I'll give you a little morsel of wisdom, and you'll go away and you'll try a bunch of stuff, and then you'll come back, and you don't have to learn it all at once. I promise you. It's enough to just know this. If you write integrated tests, then you run the risk of making your tangle problem worse. If you rely too much on integrated tests, that tangle problem is probably going to get worse. And at some point, you're going to want to just flip a table and start again. Don't let that happen. Before it gets to that point, come back and ask me a question. And now when you've asked me the question, hey, have you thought about trying to do this thing called collaboration tests? And then when they've done that for a while, then at some point they'll come back and say, well, I don't know how to make the collaboration. I don't know how to trust my collaboration tests. Okay, now, have you heard about this thing called contract tests? Because contract tests will help you fill in the gaps in a way that's more effective than integrated tests. You'll probably use both together, but I think most people over-rely on integrated tests and under-rely on contract tests. And yeah, it's not as flashy. It's not going to make the main stage at many conferences, but it's going to be a hell of a lot more effective. When you feel the scam taking hold, here's how to protect yourself. That sounds lovely to me. Not, you're doing it wrong, but look, this is a thing that happens to everyone. It's part of the learning process. Don't feel bad. When you start to notice that adding more integrated tests doesn't seem to make the situation better and might even be making the situation worse, come here, yell right here. And after you've got that out of your system, we can talk about what step to take next. And if you're not feeling any pain, then I guess everything's cool. Maybe you have accidentally mitigated the problem by making your clusters small enough. Works for me. If there's no pain, then there's no scam and there's no problem. Keep going. When you start to feel pain, come back and see me. So, not integrated tests are a scam. How about collaboration and contract tests? Use as needed. Not sure what that means? Ask me and I can help describe it to you. Collaboration and contract tests when you can, integrated tests when you must. Not integrated tests are bad, but just they're not your first choice. Again, sounds pretty reasonable. Prefer composition over inheritance. Prefer collaboration and contract tests over integrated tests. We're having pain. How are your integrated tests? That's part of where the pain is. Okay, try collaboration and contract tests. Now, there's still some issues that we need to address here. I'm not going to go into all of them here. I'll just highlight them. There's still lots of antipathy towards test doubles. People don't trust mock objects. And part of that is because they've seen what happens when you have indirection without abstraction. I get it. It's a lot out there. Part of the problem is that I believe that's part of the learning process. I think you have to write those terrible tests in order to understand why they're terrible. And the reason why people get stuck in the pit is that they don't have someone like me that they feel like they can ask for help. I don't know why. I keep yelling at people. You can ask me. It's fine. Programmers don't like to ask for help. They don't feel like they can. They feel like they're supposed to know everything. They have a lack of confidence. Some of them have full-blown, imposter phenomenon. I don't know. But that results in a whole bunch of mock objects are evil things, which we know aren't true. But that's a bunch of noise that we're going to have to keep dealing with, I think, for the rest of our careers. Until everyone switches to functional programming and then thinks they don't need test doubles anymore. They're wrong, but they'll figure it out. It's fun. There's still lots of confusion about the different kinds of test doubles. When to use stubs, fakes, spies, expectations, or actual mocks. And in fact, that's the next point, right? There's also confusion between mocks and mocks. Do we mean mock objects as method expectations? Assert was called. Or do we mean mock objects, the synonym for test doubles? The best way to find out is to ask. But that's part of the confusion. The terms themselves, Gerard Mazzaro still has that translation table in his book, X-Unit Test Patterns, of this author, when they say stub, means this, and this author, when they say fake, means that. I mean, I just, when I saw that table for the first time, first, I was honored to be in it. Second, I thought, that's hilarious. We are so disconnected, fragmented, and disorganized as a community that someone needed to put a translation table in a book. So imagine how hard it is for the poor programmer who's trying to pick these ideas up and thinks that they need to learn it all by themselves. And then you add the whole handcrafted versus factory produced, test doubles. I don't think it makes a difference, but there are people who have stronger opinions. And then, of course, do I use contract tests or integrated tests? So these, I think, are the issues that we need to address over the coming decade. If you are looking for something to write about these things. Flood the market with ideas and let's see which ideas rise to the top. Stop telling people that they're wrong when they say mocks are evil. Instead, listen for how they're right. Good excuse. I wrote an article not that long ago called "You Don't Hate Mocks, You Hate Side Effects." Again, kind of a crappy title, but marketing is hard. Because that's, I believe, what people are pointing to. Again, I think the test doubles and the proliferation of expectations in a test are a symptom, not a cause. And the cause is too many side effects. Either the side effects are tangled or they're too complicated. There's abstraction missing. Too many details are being exposed. And if you are allowing your tests to drive your design, then you'll look at the proliferation of expectations in a test and you'll say, wow, there's too much detail here. I need an abstraction. Now, some people will write articles that are like, see, mock objects are evil. And when you rearrange your design to get rid of the mock objects, then everything gets better. And they conclude from that, therefore, mocks were the problem. I mean, that's not how logic works, but look, I'm willing to let people be wrong on the internet if it helps them move in the direction of a design that's ultimately going to be better for them. I'm okay with that. Let them be wrong. It's fine. At some point, some of them will write an article that says, gee, I was wrong. Mock objects were the symptom, not the cause. I've seen the light. There's no rush. I'm not selling mock objects for a living. It's fine. Let people be right for the wrong reason. Now, I don't like to use words like right or wrong here, but in a headline, nuance is not easy to add there. Stamping out test doubles means moving side effects up the call stack. It means moving in the direction of the functional core imperative shell. Great. It means essentially sprinkling some functional programming magic dust on your objects. It means using the dependency inversion principle as if you meant it. Or I like this one. I came up with this one at the end. I was kind of proud about that one. Growing FP-style pure functions guided by tests. Steve and Nat, I hope are you listening? Can you write that book? I think that'd be great. Let people be right for the wrong reason. If they end up joining us in the nice happy valley where the designs are nicer and tests are smaller and feedback is quicker, I don't care which road they use to get there. It's all good with me. And then we can have some discussions over coffee or wine or whatever, talk about our experiences and learn from each other. I think it'll be fine. I would rather reframe the debate that people who are struggling with integrated tests are not doing object-oriented wrong or functional programming is better than object-oriented. I think it's just, like I said, I'm sprinkling some functional programming on my object-oriented. That's fine. If they want to hate test doubles, let them hate test doubles just as long as whatever they do guides them to refactor in the direction of a design that is easier to maintain, that is less expensive to maintain, that defers becoming legacy code as long as possible. And as I said, if they want to believe that they got there by ruthlessly eliminating those evil mock objects, I'm okay with that. Again, I'm not selling mock objects for a living, so I can say that. If you're selling mock objects for a living, I understand you might have a different opinion about that. The urgency level matters more for you. But then you can write those articles and keep saying, no, folks, mock objects aren't the problem. They're the symptom. Now, I've seen some stuff about testing without mocks, and I know I mentioned James Shore earlier. I'm going to mention him again. I'm disclaimer, I have not read his work on nullable infrastructure in detail, but I read some of his early stuff on testing without mocks, and it seemed to have a bunch of mocks in it. Now, not expectations, but stubs, fakes, whatever you want to call them. So which mocks are we talking about when we say mocks? That's part of the confusion I mentioned earlier. Because it would be very easy, and it was easy at the time for me to say, he says testing without mocks, but he's using mocks. Okay, I felt superior for like 30 seconds, but I'm not sure what other value that had. And, there's just a little bit of passive aggressiveness there, I still prefer to detect side effects directly using expectations rather than relying on knowing the details of how the production system happens to react to those side effects at the moment by saving things to the database or by writing a file to a file system or, firing another event. But, you do what makes you happy. There's a fine line. In fact, the only difference between delivering this with passive aggressiveness and delivering this with genuineness is how much they trust you. Because it can sound the same. No matter what tone of voice you use, if they don't trust you, it'll be passive aggressive. And if they do trust you, then it'll be genuine. You do you. I don't love the framing, but I like the results. The bottom line, I don't like the idea of people thinking mocks are evil and that removing mocks is their mission in life. But if they get there, I'm happy. We can use something like clean language to help us avoid the mistake of saying, you're right for the wrong reason. And instead ask a question. One of the magic questions in clean language is, what kind of mocks are your mocks? Oh, so when you say mocks, you mean specifically expectations and not test doubles in general. Okay, cool. Because, for historic reasons, sometimes we use the term for both. Now I understand you better. And so I can now put my giraffe ears on and I can read testing without mocks as testing without method expectations. And I agree with it 127% now. All it took was asking one question. Now, I'm going to ask you, and this is particularly, when I say you, I mean the folks who are selling collaboration and contract test ideas, tools, techniques as a way of earning money. Are you feeling over-responsible for this confusion? Are you feeling over-responsible for people not getting it? Are you trying too hard to convince them what's right? It's pretty common. So there's a wonderful little book called The Responsibility Virus. I highly recommend it. It's where these terms under-responsible and over-responsible come from. And the bottom line is over-responsible means taking more responsibility than you need. Feeling responsible for something over which you have no control, over which you have no influence. The confusion about terms is never going to go away. As soon as two people try to use the same words, they're going to mean different things. Now, instead of 2, make it 100,000 and you have a serious problem. The confusion about terms was never avoidable. There was nothing we could do about it. And instead of seeing it as a problem to solve, let's see it as what it is. It's evidence that our ideas are popular. Maybe not as evenly understood as we'd like. Maybe we need to work a little harder or try some different things to communicate them. That's part of what I'm here for. That's part of why I've changed the tone of my presentation. I'm tired of preaching to the converted. That's not my intention anymore. I want to open it up to everybody else. I want to invite everyone into the tent. And so this confusion about mocks and all that stuff, to me, that's not evidence of misunderstanding so much as it is evidence of people paying attention. As Reggie Jackson once said, they don't boo nobodies. So let's go for it. Let's jump in let's go to where the confusion lies and offer to help. And not tell them they're right for the wrong reasons or that they're wrong for the wrong reasons, but to actually listen to them and offer to help. So let's use the old extreme programming joke. It's Chet's fault. Now can we have an adult conversation about how to solve the problem? Who cares? And in fact, it's nobody's fault. It just is. When ideas become popular, they become misconstrued because language is hard, because understanding is hard, because the way to build shared understanding is to talk to each other, and you can't get that as effectively from a book. That is the law of raspberry jam again. The wider you spread it, the thinner it gets. Not going to worry about this. Now, collaboration tests, I think, are pretty mainstream by now, but Programmers are still struggling with losing track of what they're trying to test. They have 12 mock objects. They lose track, and it's difficult for them to understand what's going on. And when they lose track, they get frustrated and they give up. And this is an area where I think we can really help by writing more good examples of how to write good collaboration tests and how to write good contract tests. I think what's missing is the book on how to do collaboration testing well. Growing object-oriented software guided by tests is one, but I think we might need a book with mock objects in the title to get people to really pay attention. I have tried to write this book for 12 years. I'm not going to do it. So one of you needs to do it. Where is the, mock objects for the confused? Someone, please start writing an outline now. I can at least help with ideas. But I can't write this book. It's not coming out. I've been trying for a long time. It's just not happening. I can't explain why. So one of you needs to do it, or somebody needs to do it. Start by just writing better examples. In the meantime, my goal is to present all of these ideas not as a failure of technique, but as a natural part of learning. The falling into the pit with mock objects, the failing to understand abstraction, all that stuff is just, there are things that happen when you try. And the best I can do is to make myself available to answer questions. So now, what are contract tests for, really? Let's furiously get to the conclusion. I think people still have difficulty understanding how contract tests fit into their overall testing strategy. How to write contract tests, there's lots of great tools and documentation about that, but I still think well-meaning people try to write contract tests and then don't understand what they have when they're done. I think this is an area where we need to do better. So I like to say things like, well, start with learning tests and then extract contract tests. Write tests that document your understanding about what that thing does, and then figure out how to extract it to become a test for the abstraction. Or you can think of it as the contract of a thing, an object, a module, whatever, has two parts. There's the syntax, which the type checker will handle, and the semantics. What are the rules? What are the rules of behavior? If you put in this kind of input, you get out an odd number. Those contract semantics, contract tests are a way to document the contract semantics by example. Instead of writing paragraphs that are promises about what you're going to get, preconditions, postconditions, all that stuff. We're not trying to go for formal methods. We're trying to go for documentation by example. And the contract tests are examples of the contract semantics. This is what we mean by that paragraph up there. And this will lead us to clearer published APIs, not just HTTP APIs, all APIs. I don't remember when it was that everybody decided that API only meant HTTP endpoint. Sorry, folks, we've been saying API since, I think, the 70s. Objects are APIs too. So let's try a few pithy ways to describe contract tests and see how they feel. Contract tests are merely examples of using an abstraction. Right? We can go back to the abstract test case idea. That was one of the first contributions I ever made to the Ward Cunningham's wiki. Was I fixed a bug. I had to write an adapter to the IBM Enterprise Java Session Bean interface because abstraction because they used an enumeration incorrectly. It was a situation where there was no element. There was next returned false, but instead of throwing a no such element exception, it returned null. And if you read the documentation for Java's enumeration, I mean, it's been the same since version 1.1. If next returns false, then when you try to get the next object, you're supposed to get a no such element exception instead of null. And was there IBM's access beans. So I found a bug in their contract by using this thing called an abstract test case to show that the problem wasn't merely with one implementation of an access bean, but the abstraction idea, the contract was broken. Their access bean did not behave like an enumeration. That's all it was. A contract test is just an example of how to use an abstraction. And that's it. Do you actually behave the way the abstraction says you should? When you try to hide those details, Whatever details are left behind that you expose to the public, do you actually play by those rules or not? Doesn't sound that hard. Don't need a tool for that. Just write a test that focuses on the idea of, when I use this abstraction, I expect this to happen. And it doesn't matter which implementation I use. Every implementation should behave the same way. That's a contract test. Contract tests are merely examples of how to use a published API, which is saying the same thing. But instead of abstraction, I said published API. Because published API is more popular, I guess. More people will understand what I mean. And if they think about this long enough, they'll probably end up here. Contract tests are merely documenting the commitments of the supplier. You can depend on these things. These are the behaviors that we commit to keeping stable. This is how this thing works. You can trust us. And if we break our promise, you can yell at us and we will listen. Sounds wonderful. What a wonderful way to earn trust than to say upfront, when I say that I implement that interface, or when I say that this is the abstraction, this represents how I work, you can trust me. No matter what happens, these stuff stay stable. Now, the only difference is that with contract tests, we're testing the abstraction instead of the implementation. Contract tests are merely documenting the assumptions of a client, which is saying the same thing from the client's point of view. When I use you, these are the rules of behavior as far as I understand them. And so this is when you're writing contract tests from the point of view of the supplier. This is when you're writing contract tests from the point of view of the client, but they mean the same thing. When you say it this way, it doesn't sound difficult, I don't think. It doesn't sound unusual. It doesn't sound weird. Where it fits into testing strategy, I think, becomes a lot more obvious. And look, it doesn't matter to me which of these formulations you use. As long as one of them helps you, I'm happy. You can start there and you can learn the rest later. The fact that those four things are equivalent to each other might not be obvious on day one, but it might be obvious on day 1,718. It's fine. We're all waiting in the happy valley for you. You can come when you're ready. And how will we know that our efforts are working? Our efforts to demystify contract tests, our efforts to describe using collaboration and contract tests in a kinder, gentler way. When the memes change. When the memes change, then, as not Gandhi said, blah, 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 then they fight you and then you win. When the meme says this instead of 0 integration tests, we'll know we're making progress. And that's all I wanted to say today. Here is where you can find me when I am not chasing my dream as a professional 5-pin bowler. That's where you can find me. You are always welcome to ask me a question. I'll repeat the joke. As long as you're willing to wait indefinitely for the answer, that service is free. And if you need a better service level agreement, we can talk about how much that costs. It's less than you think.
Brilliant.
And that's all I have to say.
Thank you, JB. That was awesome. It was possibly slightly different talk what I was expecting, but I loved the bit about the focus we had on how these things are difficult, and the hardest bit is like communicating the concepts, right? That's that personally resonated with me. I know you've been up really late. And we are slightly running over time. I had a couple of quick questions, but if you want to,
I'm willing to answer as long as you're willing to put up with it. Go ahead.
Okay, cool. Let me just share my screen a second and then take it away from you. So the first one really was, and you did really touch on this. So I'll probably just elaborate a little bit more.
Sure.
And this came up a bit during some of our other talkers during the day. Do you feel like some teams need to fall into the hole before they start solving these problems? As in, they need to feel the pain, and you did kind of allude to this, or did you feel that builds a better learning and understanding for teams generally as it goes on? Basically, I'm trying to say.
The short answer is yes, but so I get a bit nervous with the whole need to feel the pain thing, because that feels a little bit like, well, you need to, because I suffered, you need to suffer, and I definitely don't mean that. But it is true that, one of the things that we know about what motivates people to try new things is when the pain of uncertainty of the new thing becomes less than the pain that they've grown accustomed to. And so I wouldn't say they need to feel the pain before they'll get it, because I didn't feel that much pain, but I was attracted by the ideas and I thought, ooh, this will be better. Some people will come at it that way, but I would say the opposite, that letting them feel the pain longer, I don't think is torture. I think it's patience. That some people, before they really feel like they need to change, need to experience how bad things are. The difficulty is that if you let them feel too much pain, then they learn helplessness and they give up.
Yeah,
that's a very tough balance, and that's why I'm not comfortable saying they need to feel the pain, because if you inflict pain on them, or if you push them in the direction of pain, you risk them learning helplessness and giving up before they get to the good stuff. Yeah, so I'd rather say the pain is part of the natural learning process. I
can understand that as well. Like,
yeah,
there's a guiding, some guardrails. I think if you're that experienced person with that experience, that knowledge, not to let people get to a certain point, right? But
I worry about guardrails too, because guardrails stop people from gaining experience, right? Experience comes, or was it good judgment comes from experience, and experience comes from bad judgment. So you have to be allowed to make mistakes. You have to be allowed to have the wrong ideas. You have to be allowed to do silly things so that you can understand what's silly about them and then never do them again. I think that's what I mean by the natural learning process. And I worry that a lot of senior programmers try too hard to take away too many learning opportunities from juniors, and they end up being those people who say, well, I know I'm supposed to use these mock objects, but I have no idea what I'm doing. And then we end up with the kinds of tests that we then end up trying to come in and clean up the mess.
Yeah.
They have to be allowed to do silly things to learn why they're silly. That doesn't mean that they need to do silly things. They need to be allowed to do silly things.
Yep. Okay. Well put. And also, without any experimentation, we won't get innovation. So
right, exactly. We might find out that there's actually a better idea than all of us in the room know.
Yes.
And usually it's a junior programmer who discovers those anyway.
Exactly. So today we had, and again, you touched on this towards the end. We were talking about the implicit versus explicit nature of schema versus behavior. So we think about like Pact itself, its origins, it might be evolving into something else, but it solves very specific problems about contracts between REST API microservices. That's moving on now. And some of the conversations, right? You have explicit sort of network contracts now, like gRPC we were talking about earlier today, and you've got things like Open API. What are your thoughts on schema, sort of the explicit schema kind of behavior versus implicit sort of behavioral problems that something like Pact will solve between testing things like microservices?
Well, so I infer that schema is close to what I mean by contract syntax, the sort of the shape of the thing. What's a valid message to this module? The kinds of things that a type checker would check in a language that has a compile time type checker, for example. And then behavior sounds like it's more of the contract semantics. When you do this, this will happen. These inputs will turn into those outputs. This will cause those kinds of side effects. I think this is an idea that had been missing from what we've been teaching for a long time. That I think that's again, this has contributed to this idea of people sort of having a vague notion that contract tests, that they should do them, but they're not sure why. And it took me quite a long time to evolve this notion of syntax and semantics by making it alliterative. It's easier to remember, to try to sharply delineate the two kinds of tests that we care about, making sure that the wires will fit together. That's the syntax bit. And then making sure that the components will actually behave sensibly with each other. And that's the semantics bit. And where contract tests really come in is, I think a lot of people had the picture that contract tests were like a substitute for a type checker in languages such as JavaScript, Python, Ruby, where you don't have one. I think that's kind of where you're stuck for a while. And gradually, I think now people are really getting the idea that contract tests really shine by showing examples of what we mean by when you use my thing, here's how it's going to behave. And I think that's where these tools really have promise, is in focusing on the contract semantic side of things, because that's usually where the problems are. The problems seem much less to be, oh, your message is in the wrong format, or you've called a method with the wrong number of arguments, and really are, you thought we were going to return null, but we threw an exception, or you thought we were going to return, or especially, I don't even know what type of thing you're going to give me. Why don't you show me some examples? And that's where I think really contract testing can continue to become really helpful. I think there's a lot of untapped potential value there. I'd like to see that message be clearer so that people then have a clearer picture of how contract tests are going to help them, rather than just, my buddy, the senior programmer, told me that contract tests were good, so I'm going to shove them in my project somehow.
Yep. I think you sort of alluded to this quite a bit during the talk as well. We were just discussing this offline as well. I think that consumer test first thing as well is often understated in what we push for in the Pact sort of community, and obviously comes from people like yourself. So I have one last question, and this one hopefully is a bit more just personal comment. What would be, if you could give your younger self one piece of advice going through like your sort of journey, and we talked about, I'd love to hear about the origins of the word scam, by the way. What would that be?
Everyone around you really is absolutely doing their best. They are, in fact, not idiots. They are doing their best. They're under stress. They're under more stress than you. And that's why they make decisions you don't understand. So enjoy the fact that you don't even know what stress feels like yet. When you feel stressed like they feel stressed, you'll make the same stupid decisions they do, and they'll make perfect sense. That's the message I would like to deliver to 26-year-old me.
Awesome. No, that's a pretty good message. I think I probably wouldn't be too far off that myself. Okay, JB, I'm going to try and wrap up now. Thank you again for your talk. It was really, really awesome. I think sort of echo everyone else on the chat as well. So on the stream. So I will let you get some much needed rest. By the sounds of it, sounds like your journey back has been a bit of an effort. So
if it helps, I'm wired right now. I'll probably collapse later. So I'll at least so don't worry about me. Thanks very much for the chance to talk, and I apologize for stealing a little bit of your time.
Oh, no, that's all good. That was all excellent. So for everyone else, so we are in the process of wrapping up. So what I would like to sort of finish on firstly is that we've had some big revelations today, from Ron's GitHub handle to Sam's love of the Rabbitohs to where the origins of scam came from, which they've all been brilliant, by the way. We were just discussing some of us online in our Slack channels that there is a bit of a theme around like schema versus contract tests, and that is something, there was a community that we need to communicate those ideas better. That came across, I think. The testing pyramid as a model, that got commented on a few times as well today, and that, all models are wrong and some are useful. And I think sometimes people getting held up by thinking about the testing pyramid without actually thinking about the context. Again, I think that's sort of language. I hope for a lot of you got a bit of nostalgia. So like for me, like listening to Beth, Ron and Matt, having known them now for 10 to 15 years, it's quite nice hearing some of the origin story again. But I hope like meeting some of the people who contribute to Pact, some new faces as well, really help understand where it's going. It's not just about REST APIs anymore. Obviously, there's more and more distributed things that we are doing. So while the idea of contract tests and collaboration tests are really valuable, trying to fit into these modern architectures, I think you can see the direction. So in my wrap up, hopefully my slide will move. We were going to do questions. There were a couple of really good ones in the YouTube channel, I believe. So I think we're just going to try and answer those in the Slack group, just because we are like 15 minutes overdue now, and it has been a long day. And poor Matt, I don't know what time it is there and how many whiskey sales he's had, but I can't believe he's still standing. So we do need to do that. But just last slide, please do if you're not already on our Slack channel, so slack.pact.io, please come there. There is the welcome channel. There is a Pactober, as I mentioned in the first slides. There is a Pactober channel, so you can put things specific for this. There are more events coming up, so please go check out there as well, and you'll be able to see all the other stuff. So it's a whole month. And if you want to give feedback specifically for this, we do have a type form. So I was going to end there and thank all the speakers who have spoken today. Like, I think we've been really, really privileged and lucky to have the talkers that we've had, and I've really enjoyed it. And I've had a blast doing this. And I would like to thank you all for your time, and hopefully you found this really useful, and hopefully some content to come back to. So with that, I will wish you a good morning or good evening, wherever you are.
Thanks, everyone. Thank you, Elliott. You did an awesome job. Thanks to all the speakers as well. Absolutely amazing. Blown away.
Thank you.
Thanks, everyone.
Amazing. Thank you.